So in summary, as you can see, Artifactual manages quite a few processes and software applications hosted within MoMA's IT environment. So Artifactual is doing this based on two services that we recently developed. The MoMA team realized we needed to focus more on art conservation and collection care, so we decided to approach Artifactual about being more of a digital preservation service provider. And as a result, we now have two services called AMPS and PSMS. I was able to write the agreements for these two services by having a deep understanding of MoMA's needs and by leveraging the longstanding relationship with Artifactual and the trust that we'd built. But any institution could develop a flavor of these services that could work for them. So AMPS is the Artifactual Managed Preservation Service, and this involves day-to-day operation of the AIP or APE creation and storage system and focuses on packaging. So if you're unfamiliar with that term, it's from OAIS and it stands for Archival Information Package. This includes taking bags created with Bagit from our designated transfer source, pre-ingest directory, and creating APEs and then routing those to the appropriate storage locations. And PSMS is the Preservation Storage Management Service, which focuses on long-term bit-level preservation and extends AMPS by adding storage management and digital preservation services. And so now Micah Boss will demonstrate the highlights of these two services.
Thank you, Amy. Hi, everyone. My name is Micah Boss, and I am a digital preservation specialist working at Artifactual, and I am MoMA's current client manager. So moving on to the demo, we will start at the beginning of the preservation workflow with managed processing. At this stage, we will make use of two applications, the first of which is called Enduro, which is a new automation tool built by Artifactual to support advanced Archivematica setups and integrations with other systems and workflows. Enduro is designed to automate the processing of transfers, specifically within multiple Archivematica pipelines, but it also facilitates batch ingestion, which is what we make use of in MoMA's case. Of course, then, we have Archivematica, which, as many of you will know, is free and open source digital preservation system that is designed to maintain standards-based long-term access to collections of digital objects. So Enduro essentially wraps Archivematica and provides a new UI with additional functionality when launching a SIP or submission information package for preservation. And with that, I will move to a screen recording that I prepared just in case of connectivity issues. So here we are. Go ahead with this. So the first thing we need to know is that MoMA groups their SIPs into batches, which are placed in the staging area on their production server. This staging area is divided into three sections, each corresponding to the intended storage location of a batch. So here we have cloud, we have local, and then we have VDAM. So as you can see here, I am currently in the pre-ingest staging area on MoMA's production server. There we are there. So once a batch has been placed in one of these three directories, MoMA staff email me to inform me that a new batch is ready for processing. And we will now navigate into the cloud staging directory. And I'm going to list out the contents. And you can see here that I have a number of batches that are ready for launch. So today I'm going to be working with the 2025-09-23 cloud batch, so this is September 23rd cloud batch, which is this one here. So if I open up this batch, which I'll do in just a second, and list the contents, you can see that I have a number of directories with artists' names at the beginning. Within these parent-level directories, once I list out their contents, you can see that I have a number of directories now with alphanumeric strings at the beginning, or as a title. These alphanumeric directories are the SIPs that we are going to process into APEs. They are formatted using the Library of Congress Bagit format and are named according to a convention that allows MoMA to create a connection between the preservation system here and their external database, TMS. So within one single artist directory, we can have multiple SIPs, multiple bags, and as you can see within a batch, we also can have multiple distinct artist directories. There we are. So to start the preservation process, I will first locate the batch in the relevant staging directory, inspect the structure, permissions, and size of the batch, and make adjustments as needed, and notify MoMA staff in the event of any structural issues that might affect ingest, so issues that might result in bag validation failures, for example, in Archivematica. And once these verification steps are taken, we will navigate to Enduro and we can actually launch the batch. So what I'm going to do here is I'm going to copy the file path to this batch directory, and I'm going to head over to Enduro. So here's the Enduro dashboard, and you can see here that we have a number of SIPs that have already been successfully processed, which are all listed here in this central grid area. But to launch a new batch, I am going to navigate to the batch import form, which is located in the upper right-hand side. Just a second, there we are. In this form, the first thing I'm going to do is input the file path that we just copied from the command line. There we are, there's our file path, there's our batch. I will then go ahead and fill out the rest of the form following MoMA's workflow. So you can see here that I've selected their integrated Archivematica pipeline, and I'm going to select the processing configuration that corresponds to the location of this particular batch, so of course cloud. I will then ensure that the type is unzipped bag and ensure that the following 3 settings are enabled. These are customized features designed for MoMA to facilitate their specific workflow. And this is the great thing about Enduro, is that it does have the capacity to have this level of workflow customization. I will then select the depth, and this is where Enduro is going to find the SIP in the designated file path, the location. And then we will come to the completed directory field, which allows us to specify the path where transfers are moved into when processing has completed successfully. I will then go ahead and hit submit. And back on our collections page, you can see here that we now have the 4 SIPs that we saw back in the command line currently launched. I have 2 in progress, as you can see here, and I also have encountered 1 error, which we have time we can take a look at. But moving on, I will quickly now switch to MoMA's Archivematica dashboard, and we can see here, once I do a quick refresh, that the SIPs we just launched are currently being processed. So if I copy this name here from this SIP that's currently on the transfer tab, and quickly navigate back to Enduro, just to highlight, this corresponds to one of the packages that is currently listed as in progress in Enduro. So really, Enduro acts as an alternative, more user-friendly UI to Archivematica, and also provides an opportunity to clearly launch SIPs in bulk rather than painstakingly manually launching individual transfers, as has historically been the way with Archivematica, unless you're using automation tools. But in the event of a failure, as we saw, I would normally perform an investigation. I would inform MoMA that I encountered the error, and we would resolve it from there. So the end of this part of the workflow comes when all the apes have been stored successfully and have either entered a success state or a failure state. And in the event that everything has been completed successfully, we go back to the staging directory and clear out the now empty artist directories in that batch folder and prepare for the next batch. And that brings us to the end of the managed processing section. I'll just quickly hop back to our deck. Oops. There we are. Great, there we are. Okay. So moving on to the storage management portion, Archivematica is accompanied by the Archivematica Storage Service, which is the mechanism by which Archivematica is able to store packages and manage file locations. Alongside the storage service, we also have 2 independent cloud providers with whom we store replicas of a high-value subset of MoMA's material. The first provider we work with is Backblaze, which is hot storage, so online and readily accessible. We then also work with Microsoft Azure, which provides cold storage, so replicas that are offline and have delayed access. And I will now demonstrate this portion of the workflow by heading to our, there we are, next video. So moving on to storage management here. Now that our 3 remaining SIPs, as you can see, have a status of done in Enduro, this means that they have been completed or successfully processed and stored in Archivematica Storage Service. We will now review the results in the Archivematica Storage Service. So the first thing I'm going to do is navigate into this package record, and I'm going to copy the name of this ape. And then I'm going to navigate into the storage service and enter that into our search field. And as you can see here, that search has yielded 3 results. So we are now going to take a look at some of the pieces of metadata here. The first field I have is UUID, which of course is the unique identifier of the package that was assigned by Archivematica during the process of going through Archivematica. We then have the originating pipeline. We then have the current location of the packages in storage. So again, just those 3 file paths. We'll return to this field in a moment. We then have the size of the package, the type of package, of course being ape. We have the replica of column, and again, I'll return to that in a moment. We then have the status of the package, which of course all 3 of these entries are uploaded. And then lastly here we have the date it was stored. So if we look at the current location column and do a quick search for the name of the ape, you can see that all three of these entries share the same name. The first result in the list is what we call the primary copy, and it is stored in MoMA's Ape Store in the cloud subdirectory, as we can see from this file path that I've just highlighted. These primary storage locations, or what we sometimes call data pools, are managed by MoMA IT and are located on local disk with additional backup. If an ape has been stored in the cloud primary storage location, as it has here, 2 replicas have also been created using rclone and are stored with 2 independent cloud providers that I mentioned earlier in the presentation. Of course, Backblaze for hot storage, Azure for cold storage. With this in mind, if we look at the 2 subsequent results from my search, we can see that they have the same ape name. However, in the UUID column, they have distinct UUIDs. If we navigate over to the replica of column, however, this shows that these 2 secondary entries are replicas of this primary copy. And we can identify this because the primary copy's UUID is populated in these 2 secondary entries. We can now navigate to Backblaze itself and locate this ape using this file path here. So I'll just quickly flip over. So here we are in Backblaze, and as you can see, we are at the exact file path from the storage service. So starting in MoMA's production bucket, we start with the first breadcrumb and we work all the way down to the actual package itself. And now that we are in the replica copy of the ape, we can see that we have our Baggett tags and the payload under the data and then subsequently the objects folder. Here's our MP4 file, that is the payload of this particular package. Similarly, in Azure, we can see that we have followed the file path taken from the second replica entry in the storage service. So here we have the breadcrumbs, again, starting with 555C, leading all the way down the line to the actual package itself. There. And just to highlight really quick, this is the file path you can see here, starting with 555C, moving all the way down. So again, here we can see we have our Baggett tags, and then we have our payload under the objects folder. Again, that same 624 MP4 file that we saw earlier. I'm just going to quickly pause here. The final piece of MoMA's preservation workflow is fixity checking. So to verify the integrity of both the primary copies of apes along with their replicas. So for fixity checking primary copies, we use the fixity application that accompanies the Archivematica storage service, which can be run using a very simple command that can be run from any browser. So I have just input this here. I've blurred the first part of this because that is the production URL of MoMA's storage service, so I just blurred that out. But the only part I want to highlight here is this bracketed UUID portion. So to run fixity, I simply have to replace the bracketed portion here of UUID and then input the UUID of the primary ape, which I would like to check. So I'm going to do that now. I'm going to grab the UUID here for our package, and I'm going to paste that in this section here. I will then run the command, and it will provide some very basic output, but it does the job. So you can see here that under the success parameter, it is listed as true. This means that the check was successful. There were no fixity errors detected. And just to highlight again, there was no output under the failures parameter. So this would be considered a successful check. For verifying the integrity of replicas, we must return to the command line and run a separate script which will confirm the checksums of each individual file in a replica and confirm that they match those in the primary ape. So to run these scripts, I need to become root user and navigate to this replica import scripts directory. I will then run the following bash script. And again, the only portion that I will highlight is this UUID section here. Following that equals sign, again, I will just input the UUID of that same primary ape, like we had just done previously. So I'll do that. The script will then run. And there we go. Once it hits run, it will then confirm the checksums of each individual file in a replica and confirm that they match the primary ape. So as you can see, the script is now running. It is verifying all the file checksums in both Backblaze and Azure replicas. We have output for B2 for Backblaze and Azure for Azure, of course. And you can tell the script has finished running when we are returned to the import scripts directory. And as you can see, if we scroll back up, all of our output is green. It is successful. So over the course of each quarter, I perform fixity checks on 10% of MoMA's primary apes, primary cloud apes, 10% of their replicas, 10% of local apes, and then also 10% of VDAM apes as well. totaling just 10% of the collection processed that particular quarter. And with that, I will just very briefly return to our deck and finish off our presentation. Scooch through here again. There we are. So now that our APEs have been processed, I just want to show you the final result in TMS. So as we can see here, we have an APES UUID in the Archival Storage tab in Archivematica, which again, of course, was assigned by Archivematica. Following the processing, if we navigate to TMS, the collection management system, we can see that we have a corresponding record for that same APE, which includes the UUID in the values column. This metadata was imported from Archivematica to TMS using MoMA's custom TMS API. So while conservators and Artifactual can access the systems we've been showing you, everyone in the museum can see the digital components once they have been stored. With that, that is the end. Thank you very much.
Any questions for our speakers? Okay, just give me a sec to get around the room.
Did you archive as well on LTO, and if archive, which software you use for long-term compatibility?
We did briefly have an on-site LTO tape system, but I think that anybody who has worked with LTO knows you need the capacity in terms of staff to manage those systems, and we didn't find that we could do that on site. So we migrated our LTO tape library back to our servers and have since utilized the services described.
Hi, thanks for the presentation. I have a question for Enduro. I guess the Enduro has its own database, like a cache or something like that. But if given that I have an API pipeline who is communicating with Archivematica directly, will I then see the SIPs or AIPs back in the Enduro as well, or there's no mapping?
There's currently no mapping in that way. Enduro will only record the packages that have been processed through that piece of software itself. It has its own distinct database.
Okay, thanks.
How much variance is there in the sort of configurable options in Enduro and Archivematica? How much do you change your processing for different types of materials or file types or what have you?
So that's a good question. We, in Enduro, the differentiations between the processing configurations are actually stored in Archivematica in this distinct processing configurations. Any differences would lie there. In Enduro specifically, we run the same settings for any data pools worth of material. So again, the three distinct settings that we set in Enduro are to check for duplicates, so fail any packages that are flagged as a duplicate on name. We also retain some of the transfer title metadata in the METS file. That's pulled out with the setting there. And the third, I'm completely blanking. I do this every day. There's also a third option as well. So those are going to be the same across the board. Any distinct changes between how material is handled will be whether it's cloud, local, or VDEM, and those decisions are made by MoMA. So, yeah.
Oh, great. Okay, we're going to move on. Thank you so much. Neve's here, yay! Okay, so we're going to do a little bit of a rewind, and the talk is Foundations for the Future, Auditing Digital Collections for Long-Term Preservation.
want to say before I begin a special thank you to Evelyn and Niall for kindly stepping in and taking that time slot. Yes, traffic was not my friend this morning. But yes, my name is Niamh Murphy, and I'm the Digital Preservation Librarian at UCD Library. And today I will be talking about an ongoing project, which is the audit of digital collections for long-term preservation. So just a little bit about myself to get started. I've been working with digital collections in digital preservation for several years now. My career path has taken me through the Irish Film Archive, RDS Library and Archives, and now the University College Dublin and UCD Library. I also hold a Master's in Library and Information Studies from UCD, and I will actually begin my PhD in January with Dr. Elizabeth Mullins from the School of History. Oh, thank you. Also, I want to give a shout out to Liz. If you're watching online, shout out Liz. You're amazing. Okay, so why audit digital collections? So at UCD, our digital collections are growing rapidly in both scale and complexity. And without a clear understanding of what we have, how it's stored, and what risks it faces, we can't obviously ensure its longevity. So the audit gives us an understanding. It allows us to plan for the long term, to refine policies and practices, and ultimately safeguard our collections. So this is our approach. It's twofold. First, we had qualitative interviews with staff who are responsible for digital collections. These conversations brought out the human side, how things are managed, what the challenges are, and where gaps exist. And then second, technical analysis using Brunhild, which is a Siegfried-based file format characterization tool. And this allows us to identify file formats, check for duplicates, validate files, and even scan for viruses. So by combining these two approaches, we get a much richer evidence-based picture of our holdings. So I really did want to emphasize the people-centered side of this work. The interviews with colleagues across different library units revealed hidden knowledge that I don't believe would have surfaced otherwise. They showed us challenges, but also opportunities, and it also highlighted the champions within our organization. And this engagement ensures that preservation is not just technical, it's not a technical exercise, but that it's a shared responsibility. So on the technical side, Brunhild has been invaluable. It was developed by Tessa Walsh, and it builds on Richard Lahan's Siegfried software, as I said. But what makes Brunhild particularly useful is that it produces easy-to-read HTML reports. Let me just play that. I have a little graphic there for you. So you'll get an example there of the HTML report. These reports summarize file formats, dates, errors, duplicates, and more with direct links to Pronom for further details. It also integrates the virus scanning and sensitive data detection, which is a bulk extractor, pulls from bulk extractor. So it's a very powerful tool for digital preservation. If you're interested in incorporating this tool into your workflows, I wrote a guide of how to install and use Brunhild and also all of its additional dependencies. It's available at the DPC on their blog. So there it is, in case you're interested. So these are the results, the Brunhild results. In relative terms, I would say the numbers are big. We've identified over 2 million files amounting to about 95 terabytes of data thus far. as I said, this project is still ongoing. So as you can see on screen, the most common file categories are displayed with account and also the most occurring formats. So while we've uncovered this information, we've also uncovered some challenges. So with that, we've uncovered format inconsistencies and errors which point to potential data loss and or corruption. We have legacy media, tapes, magnetic tapes, digital tapes, optical discs, which require specialized approaches. We have obsolete or proprietary formats, which may require migration or emulation. And finally, we have very high duplicate rates across all units, which make storage costly and retrieval somewhat inefficient. So each of these challenges require a tailored solution, and they underline the complexity of our collections. But the audit, of course, isn't just about challenges, it's also about outcomes. The work supports the creation of a digital asset register. It strengthens policies and workflows and highlights the need for a deduplication strategy. So we've also discovered previously unaccounted for hardware, and perhaps most importantly, we're building shared awareness and responsibility across the library. And all of this lays the foundation for sustainable, institution-wide digital preservation. So I have some practical advice and recommendations based on conducting this work. So for those of you considering a similar project, here are some lessons learned. I would say start with the people, interviews or focus groups to gather institutional knowledge and build buy-in early, and tailor your questions to your institution specifically. Again, look out for those hidden champions. They will make your life so much easier, and recognizing and supporting them is important. Yes, like I said, this work cannot happen in isolation. It requires time, collaboration, and institutional support. So framing it as a collective effort will help build momentum as well. And then following the qualitative phase, open source tools are a cost-effective and adaptable option. The other benefit is that your methodology can easily be shared with others. But I would say test different tools to find what suits your context best. Expect the unexpected. If your digital collections haven't been audited before, or even recently, you will encounter the unexpected. There will be inconsistencies and data loss. But it's important to remember that this is not failure, it's the nature of the work. So treat these findings not as a problem, but as opportunities to identify risks and introduce measures to mitigate them going forward. Above all, see the audit as a learning process about your collections, your colleagues, and your institution's capacity for care. So to wrap up, I'd like to highlight some resources. I'm happy to share the interview template and process if others would find that useful. And here are some links to the other resources that I mentioned today, including the DPC, the blog post, and also Brunhild and Siegfried. I'd really encourage you to investigate these if you're not already using them, especially Brunhild. Not sponsored. And that's me. Thank you so very much. Happy to take questions.
Thank you. Any questions for Niamh? Yes.
Hi, thank you. A short question. You said you identified like QuickTime and ProRes in MOV. And I was
Yes.
like, what is QuickTime in MOV?
It's a lower resolution MOV, right? As far as I'm aware, more of an Access.
I was just wondering, like,
Oh,
QuickTime is MOV.
Yes.
So what's the codec? Is it really a codec called QuickTime?
No, but I think it's varied. It's I put in the differentiation basically to say we have access mobs, but then we also have ProRes mobs.
Okay. Thank you.
Is that?
Anyone else? Okay. Oh, one more question.
You know, like the weird formats, right? So how many weren't identified? How many objects didn't make it past Siegfried?
Oh, it's so difficult to say because it's across a number of different units of the library. But if I was to throw out just a guess, I mean, it's in excess of 100,000.
For what it's worth, that's not an unusual position to be in, so you shouldn't feel bad. But it's
Nice
Thank you,
follow-up.
Andy.
I think we need to go to break. So we're going to take a break. Quick note, though, from Kieran. And for those on the live stream, we'll be back in 15 minutes, 11:05 Irish time.
Perfect. I don't have much to say here, really. You can maybe follow me out to the Richard Hayes room. We will have coffee, tea, and snacks, kind of all in one location. But just bear with us, because it might be a little bit crowded, and we may end up moving some of you to another area. So just be patient. Thank you very much.
Sorry, 25 minutes. My bad.
That's great.
I feel silly now that
Hi, everyone. Welcome back. Hi to everyone on the live stream. One more housekeeping note, just a reminder, if everyone could kind of scooch in to leave some room on the ends of the rows for late joiners, that would be greatly appreciated. So first up, post-coffee break, Lotus Shears, Preserving 3D Scans. Welcome.
So test everything fine, yeah. Hi, my name is Lotus Geers. I work at the MEMO, the Flemish Institute for the Archives in Belgium. I'm going to present a presentation today. Normally, let me just check my notes here. It's made to give an overview of the first part of our journey about updating our internal preservation guidelines. Normally, this is a work I do with my colleagues, Nastasia van der Perre. She couldn't be here today. This project is focused on movable heritage. For this reason, our scope is limited to 3D scans of small and large objects. The first part is the literature study and an international survey in which 20 organizations participated, from archaeology to libraries to museums and universities. The presentation is based on the short paper that got accepted for IPRES this year, but because of time constraints, we will focus on archival formats and metadata. There are some general risks involved with long-term preservation of 3D objects, just like with any other medium. Not all formats are backwards compatible. For example, European databases containing old 3D models already disappeared because conversion to the new format had failed. There are no established standards for both file formats and metadata. There is a reliance on additional files to display textures and colors, and can make the files very complex to work with, together with a lack of documentation. So in practice, these risks increase, for example, when lacking a preservation policy. In our survey, only 2 respondents of the 20 stated that they did have a preservation policy in place. This is unfortunately very common. The focus is more on the final product and not on its preservation. The risks of not having a preservation in general, without a preservation plan, you have no idea on what formats to convert to or what files to keep, or who was responsible for the digitization process. Preservation policy also acts as a kind of technology wash to act on new evolutions of technology. So, according to the literature, what is important to keep of the 3D scans? You try to keep the raw data plus the project files. Besides that, the derivative files, because future technology improvements might also mean better quality models. This is already the case. Some older models got converted and improved the resolution. It is recommended that the archive file is an open, well-documented text-based format. The browse copies or viewing copies, depends on what organization they use the name for, access copies, should be made according to their expected use case, for instance, printing or viewing or other applications like VR. When we asked the participants of the survey about what format their archive file was in, the results reflect the fact that there is no unified decision on what archive file format to use currently. This is also what we gathered from the literature and what the survey confirmed. OBJ is still widely used because it's open and text-based, but there are some issues with OBJ in general. STL was never chosen as a sole archive format. It's open, stable, and widely used, and it's also text-based, but it's not really a candidate for an archive format. So what does the literature say about archive files? To make sure it's open, well-documented, make sure it's a standardized format. It should also be included in the PRONOM file identification list, or another file identification list like Library of Congress or Wikidata. It should preserve the properties, the functionalities as close to or identical to the raw data. It should be uncompressed, make sure it's text-based, so it's human readable. And if there's a validation tool for the format available, that's a plus. But if the format is already in an XML format, it makes it easier to validate manually. Even though these are all archive formats we extracted as potential candidates, I will focus on 2, namely X3D and Collada. So let's start with X3D or Extensible 3D. This is an example of an old 3D scan on the website of X3D. X3D was developed in 2001 by the non-profit Web3D Consortium, It's an ISO standard format. It uses scene graphs to visualize geometry. It comes in different encodings, XML, compressed binary, non-compressed binary. There are some advantages and disadvantages. X2D was developed from the ground up to be viewable in the browser. There is always technical limitations when viewing a large file in a browser, when looking at browser performance. It supports humanoid extensive features. It supports humanoid animation, spatial audio, scripting, Java, JavaScript, Java, and also soon C++. It supports encryption, virtual reality. It also supports different metadata schemes, embedding within the format. The list is very long and it's very well documented. It's very flexible. It supports various encodings. It's modular because it's explicitly structured into independent, clearly defined components and profiles that can be selectively implemented depending on the use case. It's extensible, it's open, as I already said. There's some disadvantages. It's rather complex format, so it makes it difficult for smaller institutions to implement with less technical know-how or means. And there is also an issue with adoption. Despite it being an open and flexible format, it isn't supported by all software. It's more convenient to convert to X3D, and however, it's well suited for the cultural heritage sector, specifically as an archive format. It's currently in use by Bibliothèque Nationale de France, and it's used and recommended by Archaeology Data Service. So the second archive format is Collada. You might come across it as DAE. It was developed by Sony in 2004, initially developed as an exchange file format. It describes geometry by using polygons and supports a wide range of features, and it's managed by the Kronos Group. There is, oh, I forgot to translate. Advantages, disadvantages, the same thing. I translated my notes, but it's self-contained like X3D. There is the option to include textures via external image. You can also, the texture information can be included in the XML. You're not dependent on any external files. It's also an ISO standardized file format. It's XML-based, layered metadata model, which can be extended with different metadata formats. Also the case for X3D, of course. Lots of features. The disadvantages, it can be, again, complex file format. The original validator is a bit outdated, but because it's based on XML, it doesn't really matter that much. It's recommended as an archive format by the European Commission, and the Archaeology Data Service recommends Collada in the case X3D is not achievable. So about metadata, when we asked about metadata of their 3D objects, the responses followed expectations. The surprise was that not one respondent used a 3D specific metadata format like Paradata or provenance metadata. So for long-term preservation of 3D files, it is essential to preserve descriptive technical metadata, Paradata, and provenance metadata in addition to the 3D model. The Paradata describes the methodology, the choices made, for example, the selection of specific scanning settings, the reasons for using certain processing techniques, and considerations for missing parts of the object. The provenance metadata answers essential questions about who, what, where, and when in the object's life cycle, and especially the combinations of those two metadata formats is key. Together, they provide a comprehensive documentation of both the factual history and the methodological underpinnings of the digitization process. The European Commission recommends retaining all metadata from the digitization process. Is not always possible when working with external partners due to possible trade secrets, so the recommendation is to keep as much as possible. From the literature, we can find that these metadata formats are compatible with Paradata and provenance metadata. I will not go into details about these formats because of time constraints, but afterwards you can talk to me and I can share all the notes. Eventual goal of our project is to have something like this for our internal guidelines with relevant information regarding our scope on how to preserve 3D scans for immovable cultural heritage objects. That's it. Thank you.
Any questions, anyone?
I'm coming.
I have two questions. You can only answer one if you want. I don't want to take up too much time. What would you say are the issues you mentioned with OBJ? And the other one was, I think I can't remember the name of the first one, but like it was supposed to, at least in theory, have browser support. Because I know that Sketchfab seems to be like the replayer of these things.
Yeah.
So was this like you wouldn't even need that, drag and drop in Chrome, and it should work?
No, that's not the case. Also, Sketchfab just got bought by Epic, I think, and so there's a discussion about what happens to your rights of all the objects, and people are using it very extensively. And OBJs, there is an issue is that you need an external file to display textures. So it enhances a little bit of the complexity, and the two candidates we selected were based, there were some criteria to be self-contained. I hope it answers your question. Thank you.
We have time for one more. Oh, sorry. Okay, coming over here.
That's the first time I've heard Paradata in a conference like this. It's really cool to see. You say, I'm trying to make this not sound as challenging as it might come across. When there's no extensions needed to existing metadata schemes or metadata standards to have Paradata included, but do you do anything around maybe the hygiene of that data to say, okay, this is Paradata here and this is metadata here? Do you like use namespaces?
So we are still in the process of researching what that really means in the sense for collection management systems and what those formats do. So my experience with those Paradata compatible metadata formats is limited, but we can certainly talk about what Paradata is, and it's still kind of unclear. When you read the London Charter about computer visuals and metadata, it's still unclear how much do you include in the Paradata or not. They say make it as clear as possible, but don't include too much and don't include too little. So it's kind of fresh, and everybody's trying to figure out what Paradata is for themselves. I've seen Paradata as a PDF file with like a structured table, and I've seen Paradata as an XML-based format, or an extension on an already existing format. So I'm sorry, I hope it answers your question a little bit. Okay.
All right, thank you so much.
Thank you.
So next up, we have Reto Krummer, file sizes and checksums.
Hello. As usual, the slides of my presentation are available on our website. The goal of this lightning talk is to present you some facts and figures about the quality, size, and encoding, respectively calculation time of audiovisual files and checksums. And here is the table of contents. First of all, I will spend a little time on DPX files because in the world of classic film archiving is often the preferred format for the digital long-term storage. Those who followed Jerome's workshop yesterday will recognize several elements. This is the dilemma we are constantly facing. We wish the best image quality in the smallest file size and at the shortest encoding time. In the case of the main archive format, the image quality is often considered the most important factor. As Jerome explained yesterday, there are many flavors of DPX files, some respecting the official specifications and some not respecting them. There are ARRI cameras generating log-neg encoding, ARRI cameras generating quasi-log encoding, Sometimes the logarithm is calculated on to the base 60 and sometimes to the base 90, etc., etc., etc. And of course, in an ideal world, EXR content would never be stored in a DPX files, but always in EXR files. But the reality is, of course, more complicated. Let's now switch to the file size. We resolve the dilemma we are constantly facing, not on the image quality aspect, but on the file size aspect. In fact, digital storage is expensive, and writing, reading, and verifying large files or a huge number of files is time-consuming and therefore expensive as well. For my tests, I have chosen a series of clips of just 1 minute of film in 2K resolution. I remember that FIAF recommends 4K for 35mm cinema, which implies 4 times bigger files. We run several batches of tests. The numbers for compressed formats given in the following slides are mean values. This is what happens if we store one file per frame. That's a large number of files per film. A screening time of 1.5 hours corresponds to almost 130,000 individual images at a screening speed of 24 images per second. The file size given here, as said, are just for 1 minute or for 1,440 files. I remember that today the majority of scanners worldwide work with a 12-bit sensor. If the machine delivers you a higher resolution through the software, then that's a blow-up, which is a bigger file having the same quality, but a bigger file. Often in a video and television context, the 422 subsampling is used from the beginning for the workflow on. Therefore, it doesn't make any sense to blow up and end such data to 444 sampling for long-term storage. ProRes and David mentioned here are proprietary formats. But 10 years ago, thanks to the Library of Congress, SMPTE published this disclosure document by Apple, and since then, in my personal opinion, it is perfectly safe for an archive to keep ProRes native as a main archive format. It makes really no sense to blow up the ProRes to an uncompressed format. At best, you would get the same image quality, but always a much larger file. I personally don't understand why the preferred format for access is still H264 and not H265 or even 66 or AV1, but that's not my problem here. Let's now move to the checksums. Again, this is the dilemma we are constantly facing, and in this case, for the checksums, I consider the computing time. This is not the encoding time of the files, which I skip for the sake of time. In previous preservations, I already explained that there are 2 families of checksum algorithms, the one cryptographic and the other one non-cryptographic. In an archival context, in my personal opinion, the non-cryptographic are completely sufficient. More importantly, the checksums have to be calculated immediately after the file is generated, not at the end of the workflow when the files are stored on an external hard drive for delivery to the archive. On one hand, probably the files are generated on a much faster storage than on a hard disk, and therefore, obviously, also the calculating of the checksums will be faster. On the other hand, the errors that could have occurred before the workflow cannot be detected. Using a short script, I calculated the different checksums for various data sets. I actually used a little more complex script, which exports directly a CSV file, which can then be processed with a spreadsheet, normalized and so on, in order to have a statistic sensible result. These are mean values, but the variation between the different runs was very little and always less than 0.5%. As you see, MD5, the most popular choice, is actually also the worst choice. Internally, we switched from MD5 to XX 128 5 years ago, which requires less than a sixth of the time. And at the end, we deliver, of course, to the client whatever they wish. I guess in the broadcasting community, they use mainly XX 64 in production, but I'm not sure about that, and I didn't verify the information. In the last part, I will spend a little time on raw cooked. And I must start with 2 disclaimers because I am not neutral in this matter. My company helped Jerome's company financially to turn this idea into reality. And even more, my company sponsored No Time to Wait to make this conference possible in the current form. The pandemic made a conference in 2020 impossible. Tomorrow, I will give a second lightning talk, and also tomorrow I will be in California, receiving from SEMTI a James A. Linder Archival Technology Medal. As the medal comes with $1,000 US, I will change that amount immediately into a more secure currency, round it up to 2,000 euros, and it will be transferred to Media Era for the next No Time to Wait. I often presented and mostly related to FFV1 video codec. At the first edition, together with Kirian O'Leary. Since then, I urged Kirian to organize a Dublin edition, and of course, he did. So, sorry, Kirian, and thank you, Kirian. I could not attend the 4th edition in Budapest because I was teaching in Hyderabad, and I did no presentation 2 years ago in Prague because I began stepping down from the business and preparing my retirement. Yet I'm doing 2 this year. And the 5th conference was not in Hilversum as planned, but online because of the pandemic. Since October 2019, since 7 years, there exists this bridge between the different storage of uncompressed single files and the stream compression. As you all know, raw cooked works in a transparent manner with a standard solution and so on. And this solution is based on a common idea that Jerome and myself have discussed at an in-depth brainstorming on the side slides of a Real Sync edition in April 17, I think, at the A in Amsterdam, so the world is quite small. This slide summarizes the main benefit of this piece of software, and returning to the beginning, to the DPX files, these are the flavors implemented in the current release 24.11 of RawCook. And that ends my today's lightning talk. Thank you very much for your attention.
Any questions for Reto? Okay, I'm coming.
Thank you, Reto. Please teach me. I assume that the scanners do not provide subsampling. Where do the ProRes files come from?
The ProRes files come from cameras. Many cameras can output directly ProRes.
So it's born digital?
Yes.
Thank you.
And the scanners, of course, they do the same. They convert the same way the raw data from the sensor into ProRes. And in theory, you can always modify the scanner and keep from the scanner the raw data. But some scanners, low-cost scanners, generate by default ProRes.
Thank you. So then let me add that you could always use FFmpeg in the future to decode them. Thank you.
Of course, yeah. And sometimes you have archives that are very poor. I am thinking of people like the archivists in Laos or these kind of countries, and they don't have as little money as we have. They have no money at all, and therefore perhaps ProRes can be a solution. So it's always better to do a lower quality than to do nothing and lose all the items.
Okay. Peter.
Just to confirm the numbers that you had, the runtimes for like MD5, was it 100%?
Yeah.
So basically like the slowest, and then all others were like in relationship to the runtime of doing MD5
To 100%, yeah.
Okay. Thank you.
Great. Thanks.
Yeah.
Thank you, Rita.
Are you using your own computer? No. Okay. Which one? Oh, here we got it. Dun, 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 dun. Okay. I think so. I'm not sure. We'll see. How do we? Do you have notes here that you want to see?
I have them on my phone. So
Okay. Okay. Let's just do that then. This thing. All right, everyone. Next up, Aida Garrido.
it's not plugged in.
Oh, geez. Sorry. 1 second. Is this this thing again? I think it's in extend mode. How do I pulled that up? Oh. Do I want duplicate? I don't think so.
No.
Yeah. Beautiful. Okay. The talk is called Automating File Delivery with Python from XDRoot to Archival Package to Dropbox.
Hello, my name is Aida, and I work at CUNY TV as the preservation technician in the Library and Archives Department. This presentation is about the automation of one of our ingest workflows regarding media that is delivered to us on camera cards. The XD root in the subheading refers to the nested file directory structure that is prevalent with camera cards. Firstly, I want to thank my supervisors at CUNY, Katrina Schlosser and Dave Rice, and to briefly introduce you to CUNY TV as an organization. CUNY TV was founded in 1985 as the professional broadcast station of the City University of New York. CUNY is a university system comprising 26 institutions, making us the largest public university system in the United States. We broadcast on digital and wire transmission and serve the New York City metropolitan area. CUNY TV produces about 25 original shows per season, and we possess a vast archive of original programming. We also assist academic departments across CUNY campuses with the preservation of their unique audiovisual collections. We steward several petabytes of data on LTO tape, as well as thousands of linear feet of media on legacy formats like U-matic, Betacam, and Digibeta tapes. Our broadcast archive attracts significant scholarly interest, as many of our productions follow a talk show format featuring interviews with luminaries in politics, philosophy, science, and the arts. In addition to pre-existing media, the Library and Archives Department also manages the delivery of born digital media at various points in the production process, from recording to broadcast. We are the intermediary between several stakeholders. The most essential are pictured in this diagram. When the library is delivering media, we are ensuring file integrity through fixity checks, creating derivatives and captions, and ensuring FCC compliance. At the same time that we are accommodating the most immediate endpoints for media, we are also managing files with archival preservation in mind. This is the background that this presentation is about the automating of file deliveries that pertain to one part of CUNY TV's production environment, and that is the unedited source files we receive from videographers who are coming back from remote on-location shoots. On average, we receive about 250 gigabytes of remote footage every week. It's not as much as our studio footage, but it comprises a meaningful part of CUNY TV's media. And these are very conservative estimates. These numbers can easily double depending on the production schedule. The remote footage comes to us in a variety of formats pictured in decreasing order of popularity. We mostly get footage delivered on XQD and SXS camera cards. Occasionally on solid-state drives, and recently a handful of productions have begun using iPhones as cameras. The iPhones present a challenge in this process that I will address later in this presentation. So what is the workflow? What is exactly being automated? One of the first steps of the process, ingest process, is to create an access copy for editors. This is an example of what an access copy looks like. It's a compilation of all the clips from a camera card, and they're transcoded into a lighter weight MP4 file. The access copy also features a time code and stamp on the bottom left indicating the source file. The next part of the ingest process is to restructure the footage and access copy into archival and delivery packages. Both packages are distributed to different destinations. The archival package, after being transferred to the appropriate server and directory, is eventually written to, let me touch on this first. The camera cards generally save the files in a nested directory where the clips folder contains both metadata and video files, as you see in the leftmost picture right here. The primary task in creating the packages lies in bifurcating between the two types of files and saving the data into a folder which follows a naming convention, such as this one. Our archival packages follow a specific format which accommodates other scripts in our archival processing which anticipate this directory structure. We also save the camera card data into subfolders that reflect the physical data or the physical labels on the cards. In this case, that's the number 1, and this is how we track media provenance and any hardware issues that might arise. The delivery package, on the other hand, is a flat file structure since the end user's priority is to simply access the media files. And so after the media is restructured, we send the archival and delivery packages to their respective destinations. The archival package, after being transferred to the appropriate server, is eventually written to LTO. The delivery package is sent to another server and uploaded to Dropbox, where an end user, like a producer or an editor, will have access to the files. And the final step of the ingest process is to inform editors and producers of file availability. So the benefit of automating all of that is so that the process can proceed seamlessly from step to step. Because of the size of the files we're dealing with, it can take a long time to transfer them, transcode them, and especially to upload them. It's inefficient to monitor the ingest in real time, so this leads to a latency between steps. For example, it might take an hour to upload 100 gigabytes of video. I might not notice that the upload has finished until much later than that, thus creating a delay between the upload and when the intended recipient is notified of file availability. Automating the process also creates an opportunity to validate user input. For example, the user can be warned when a specified folder name does not follow an established naming convention. In our case, we would also like to normalize folder names to all caps with all spaces replaced by underscores. Automation also ensures the efficacy of HTTP uploads. I'm sure some of you have had this problem using cloud services. With large video files, uploads can fail, especially when using the Dropbox's browser interface. These upload failures add another layer of latency in file delivery. And unless you're actively monitoring the upload, it might take some time for you to notice that something has gone wrong. Automation also allows for fixity checks, so rather than dragging and dropping the video and metadata files from the camera cards into the respective folders, a programmatic approach would more efficiently sort files with checksum validations. And all these checksums can then be stored in a log like this JSON file here. And so that facilitates the addition of another essential step in the workflow, which was previously absent, and that's a log of every ingest event, including the Dropbox upload and the second network transfer. And lastly, oh no, not lastly, but automation also normalizes email communications. This way, end users can anticipate a specific subject line and search their inbox easily for notifications like this one. And lastly, automation broadens the number of people who can perform ingest, which is crucial for the prompt delivery of time-sensitive files in a broadcast context. In the event I or Katrina aren't in the office, if we're out for lunch, our colleagues can immediately begin the ingest just by mounting the cards onto a computer and running a single command from the terminal. This was a video. So let's open this up in the browser.
I have no idea what I'm doing, by the way.
Wave to the camera.
Do you want to? We were good. We're just trying to get the.
It's just kind of playing on internet.
Those pros in automating the process in mind, we went ahead and did that. And here's basically what the ingest process looks like from start to finish. I've fast forwarded the video, so it's actually a bit slower in real time, but here we go. So we run the command ingest remote.py, and what first prints is a media ID dictionary, and people will refer to all these show codes when they're entering a package name. Just covering it up, but here there are a few other input options, and I will talk more on the one that says batch process later, but we see here there's an option to upload to Dropbox. Generally, we say yes, and then an input for specifying the person you want to deliver the file to. So it's transferring to the desktop. It's faster to do the archival processing and transcoding locally, so we don't transfer the files to the servers just yet. And now it's parallel processing these transfers. So it's being delivered to our archive server, our delivery server, and the Dropbox upload is usually slower than the other two. Sending the email notification, and it's finished. And at this point, a person's received the email, we have the ingest log, the library CC'd. In the event an error occurs, the library also receives an email, but that hasn't been happening lately. Yeah, so that's what the process looks like from start to finish. And I coded. There's some features of the script which are written to accommodate specific use cases. So one of them is we often get multiple cards from one shoot, so the script is able to handle multiple cards and process them into one package. So we see here 2 cards have been detected. And this is us processing the first card, and then the second card you get a prompt whether you want to use the folder name you've already mentioned, or if you're processing a different package entirely. And then the other use case is that we occasionally get footage from shoots where the number of cards exceeds the number of card readers. So the script is able to loop for as many times as needed, and that's what the batch prompt refers to. Is this a multi-batch process? You say yes, then you're asked, is this the last batch? Yes or no. The script itself comprises 12 scripts. They each serve a specific purpose, and they end up constellating into the workflow in this way. For the rest of the presentation, I'll briefly touch on these 3 scripts. So ingest commands wraps a couple of pre-existing bash scripts, which CUNY-TV uses to create file derivatives. The bash scripts rely on FFmpeg commands for video processing. If you're interested in seeing how CUNY-TV creates its file derivatives and access copies, feel free to check out this link and to look at these specific scripts, make window and make deriv. If you're interested in learning how to use the Dropbox API, feel free to look at the guide and practice sample scripts I put together in preparation for yesterday's workshop, Python and HTTP requests. Thank you for the people who came for that. And this is what I use to upload files to Dropbox, to retrieve their checksums, and to generate the share links that are sent to people via email. Improvements. So I alluded to this earlier, but one of the problems in creating the script was in figuring out how to navigate media files stored on iPhones. As you can see, iPhones don't mount like hard drives, and their files are not accessible through the file system. In the past, Apple used to expose portions of the iPhone on the file system, like the DCIM folder structure, which contained video and photo media. And even though the folder structure was unintuitive to navigate from a developer's perspective, it was still reasonable to manage using basic programming utilities. Nowadays, the iPhone is aggressively sandboxed, so you can only access media using external applications like Microsoft's Photo app or Mac's image capture. As the quickest and dirtiest fix, I created a UI script that manipulates the image capture graphical user interface with the help of a tool called UI Browser. This is not the ideal way of managing the iPhone files, but this is how the ingest process looks like for an iPhone at the moment. It's something I integrated into the process just a month ago. So it detected one iPhone. Might be hard to see. And then it automatically opens the image capture GUI, and I have an Apple script that is automatically downloading the latest files from the same date. And then the ingest process proceeds as you saw previously. I tried to find other tools which would let me programmatically access iPhone media files. Image capture used to have an API that has been deprecated around 2022. I've come across open source projects like Libby Mobile Device and iFuse, and I have not explored these libraries yet. So if anyone has experience using them, please let me know. So while the iPhone portion of our ingest process is still a work in progress, I wanted to share my difficulties with navigating Apple's sandboxing because it proposes some interesting questions that are of particular relevance to archivists. And that is, what is the nature and future of file accessibility? How much control will we have over our hardware and storage devices? I wanted to share this clip of Steve Jobs from 2005, which is really prescient because he describes his ambitions to aggressively sandbox people's experience with the Mac OS and his goal to make the use of the file system obsolete at the consumer level.
When I got back to Apple 7 years ago, the Finder, which is our file management system, was the face of the OS. And in every user interface study we've ever done, and I'm sure everybody, it's pretty easy to learn how to use these things till you hit the file system, then the learning curve goes vertical. And so you ask yourself, why is the file system the face of the OS? Wouldn't it be better if there was a better way to find stuff? Yeah. Now, email, there's always been a better way to find stuff. You don't keep your email in your file system, right? The app manages it. And that was the breakthrough, as an example, in iTunes. You don't keep your music in the file system, that would be crazy. You keep it in this app that knows about music and knows how to find things a lot of different ways. Same with photos. We've got an app that knows all about photos, and these apps manage their own file storage. So you don't have to go trudging through the file system to find stuff. What we've wanted to do for a while is take the last vestige of this over with something that was easy to use. And that's what Spotlight's going to do. And we're already seeing people using their Finder less and less and less. And eventually, the file system management is just going to be an app for pros. And consumers aren't going to need to use it.
So what's interesting about this clip is that in some ways, Steve Jobs is thinking like an archivist. He's talking about accessibility, metadata, index storage. At the same time, my perception of rigidly structured data, like an email inbox, is that it presents significant challenges to the archivist. The same structure and layers of abstraction which make sending and reading emails easy as a consumer is the very same structure which makes emails difficult to preserve as an archivist. As a person who first started using a PC around the year 2000, the file system was fundamental to the way I interfaced with my computer. It's hard to imagine that no longer being the case. I have to admit, in my private life, I also resent the sandboxing of the iPhone when I'm trying to back up my own photos and videos. I don't want to use a cloud service. I don't want to use an app. I just want to give my pictures new file names and store them on an external hard drive. So while it's unlikely camera cards and solid-state drives are going to stop functioning as traditional mountable systems, I think it's interesting to consider that exposed file systems are slowly disappearing at the consumer level. People are more likely to store media using hardware and services which offer access through opaque containers rather than file directories. And it's worth considering how these developments in consumer technology will eventually affect our work as archivists. And if the previously mentioned projects, Libby Mobile Device and iFuse, represent an early case study of open source volunteer projects mediating this trend in consumer technology, with the deprecation of APIs. So Dropbox has an API, but WeTransfer no longer has one. And the sandboxing of hardware, as we've seen with the iPhone, it at least proves the importance of having conferences and communities like this one.
Thank you so much. Questions? Oh, we have an online question, yes.
Okay, so it's like from the same person, so I'll just say them both together. Answer whichever you want.
Yeah.
Could the script be used or adapt for also Android, or does it work only with Apple? And do you actually receive footage on Android, or Apple is more used?
So the bulk of this process pertains to the media we get on camera cards. So this picture we see here. So we mostly get footage from the first three formats, and iPhone is a problem that has presented itself to us recently. In terms of Android, my quick and dirty solution uses the Mac Capture app. So in the case of Android, it wouldn't work. But I don't think Android has the same aggressive sandboxing as iPhone does. I think you can just plug it in. Yeah. Yeah, so this Android users are fine. Yeah.
We'll leave for them. Question here.
Thank you. I am a little bit, I think, more sympathetic to the Steve Jobs take on sandboxing, because I think it is probably fair to say that a file system as an entry point doesn't actually have to be one-to-one with what's on disk versus how you want to use a file system. I saw a really good blog post just like 2 weeks ago called Mounting the Atmosphere. Atmosphere being the protocol being used by Blue Sky for their new model for distributing their microblogging platform. And what somebody did was they implemented the Blue Sky APIs just using Fuse, using a user-level file system. You could then have file system level access all of a sudden to like your social media. That's not a native one-to-one representation of what's on a disk per se, but you've just turned an API actually meant for access into a file system, and you can work with it, and you can then adapt it because it becomes a file on a disk and a pointer and shell scripts, yada, yada. So there are ways, I think, of adapting and working around this. I mean, I remember when you could jailbreak an iPhone to get the file system, like all these lib mobile device things are gradually deprecated because nobody wants to maintain them. I think an actual solution for this community would be to put some effort into thinking about Fuse file systems the way we do codecs, right? Like somebody has to take over support for that. If you want to be able to have an endpoint to a given pseudo file system, we should treat those the way we do FFV1 or other community maintained codecs in practice. Thank you.
Yeah.
I think we have to move on. Yes. Okay. Yeah. Thank you again. I'm also handing over stage coordinating responsibilities to
Sweet. Okay. For those online, it's 7, so maybe good morning. Hi. We're very excited to turn it over to Joanna White, who also did an amazing workshop yesterday. So get ready for fine-tuning discordant workflows with Python orchestration.
Hi everyone, I'm Joanna White. I'm Knowledge Learning and Collections developer at the BFI National Archive. Just thrilled to be back at No Time to Wait, the best conference in the world. And thank you for organising it, and thank you to the BFI for letting me come. So this presentation is going to be about our DPX encoding workflows, which I have talked about a lot in the past at this event. So I'm not going to go too deeply into those, but I am going to chat about what we've done in the last year as it's undertaken some remodelling. Okay, so we've got a few overarching themes for the presentation. A reminder of our old raw cook scripts and reflections on their weaknesses specifically. Designing the new simplified code and aims for workflow transparency for developers and for users. Taking some much needed advice from LLMs, I'm sorry to say, but we have done it. And looking at the finished orchestrator running on our new workflow. And also showcasing some user interface designs for colleague interactions. So before I launch into what's wrong with the old DPX workflows, I just want to confirm it's not raw cooked. Raw cooked's brilliant. It's a wonderful piece of software that requires, that remains every day churning through terabytes and terabytes of data in our workflows. And we're very excited to test the new GPUs as well when we can. So this was our DPX repository middle of last year. The 8 folders at the top are containing code for each of our different 8 storage devices that this code works against. Each folder contains 12 scripts, 5 Python and 7 Bash. Each set of scripts were different to each other across all the different storages, which makes it very hard to update one element of a workflow because then I have to implement it across 8 different storage packages. So it was the result of organic expansion of the workflows over time and also my own learning process as I learned to be a developer, which is still an ongoing process. So what we really wanted from this aim was like one repository of code where we can fix one thing and it affects all of the different storage devices. So this was the flow of scripts for the first project. It did a lot of things. It did gap checking. It did assessment of DPXs with media conch and media info. It would split sequences up to create tar files and FFV1 files that were smaller than 1 terabyte. This was a limitation of our digital preservation infrastructure. The encoding of files used raw cooked and or tar wrapping, and it would check the created FFV1 using media conch policies and reviewing the logs and check some verification of the tar file. And it would also run a raw cooked kind of check pass as a final step before we would delete the DPX sequences. We always raw cook using the all command, which includes embedded hashes and reversibility checks. It's a very good standard for new archives who maybe want to start using raw cook for the first time. We also had the code loop back and double check any warnings in the logs that might suggest that there is non-zero padding data, which Jerome did reference yesterday in his presentation. BFI seem to get quite a lot of that. So we use something called the output version 2 flag in our workflows. We also had a couple of unwrapping scripts at the bottom right-hand side there. We get a lot of externally supplied FFV1 Matroskas from clients who have us share our license with us. And we have to unwrap them to use the DPXs. And also sometimes we need to pull tars out of preservation and unwrap those. And we use Python tar file module, which we can't unwrap with 7-zip, for example, so we've built these workflows for them. The goal is to simplify this again. There's a lot of scripts there, and we just needed like one Python script to do all of the assessment and the gap checking. So this is our Linux cron tab, which we use to schedule the scripts for our DPX workflows. Each storage has its own block, and they run 24/7, launching different stages in a sequence. If we needed to turn off one particular storage because they were working on the QNAP, for example, then I'd just be commenting all of these out. If we had downtime where we're working on all of the things, we would just have to comment every single line out. So it's nice when you're doing one script launch from crontab, but as this workflow's developed, we just had to go to something a bit more efficient. And one of the worst, messiest parts and regrettable aspects of the old workflow is the very deep and complex folder structures that built up with it, again, organically over the years. The encoding folder particularly is like a nightmare scenario of depth folders, nested folders. Users would put their files into the DPX, I think it was GapCheck was the first place they'd drop their sequences into. Then they'd just go missing, and they'd be like, what's happened? Nothing's in DPI, where has it gone? And really only the developer teams who understood the workflow interrelations with the folders could actually ever problem solve for them. So another aspect to get away from. And this is just an example of one horrifying error log for one of the files. When we have a problem in the workflow, we would generate these error logs, and then they would just keep getting added to. And over time, this one, it failed many, many times. So the same encoding problem unnoticed because we didn't have transparency over any of the kind of workflows. So to summarize, we need simpler code, cleaner folder structures, easier scheduling, and observability of success and failures for the developers and the users. It just built like this because originally it was my job to maintain that, and then my job changed slightly, and so it got bigger and we needed observability. So what we needed was an orchestrator. So an orchestrator is a tool that manages and automates complex workflows, ensuring that tasks are executed in the correct order and at the right time. Workflows are represented as a series of interconnected tasks where each task depends on the successful completion of its predecessor. We looked at Apache Airflow and Dagster as both pretty popular orchestrators. Airflow was created by Airbnb and has been around for lots of years, and it's got brilliant UI and it's got loads of online documentation. Dagster's newer. It focuses on data pipelines, testability, and it's also known to be quite a lot easier to get operational. So I first heard about Airflow at No Time to Wait 4 in Budapest. Janos Stani from Blinken, I'm sorry, I hope you said your name right, introduced their use of Airflow to run their archive microservices. It registered with me as it supports, Airflow supports both Shell and Python, and I thought, oh, easy. I can just push my scripts as they are, more or less, into an Airflow environment. That wasn't what I found. I started setting it up in early 2024, but I ran into trouble configuring the Airflow environments using Docker. So Docker is a lightweight deployment environment that helps with making projects more easily portable. Our different storage devices wouldn't mount well into a Docker environment. So, and that's kind of a necessity for me to use these scripts. They have to be able to communicate with the storage environments. What I found is that when I connected it to a couple of our QNAPs, we would have storage permission changes, and users who needed to access the storage from the other side weren't able to use it, and it was messing everything up. It needed a lot more deeper investigation than I had time for at the time. And I also heard this on a Talk Python podcast about Dagster, and it turned my head. So I thought, right, I'm just going to go and start investigating Dagster. So Dagster will work as a light environment, and you don't need any Docker environments for it. So I just thought, 100% Dagster. So the Dagster website has a really great university feature. So I started Dagster Essentials last June, which helped me build the first version of the project. I worked on rewriting all the original code, the shell, moving it into Python, and I launched my own first little mini prototype on a home laptop, using actually an example of the university repository that was part of the training package. And it was a really useful phase because it let me reflect on all of those issues that we had and combine a lot of the different shell script aspects more simply into a few Python scripts. And yeah, it's much more organized, and we've got nice folder structures now. So this is the code today as it runs. There's just 5 Python scripts, although there is actually a utility script that I've forgotten to put on here, which keeps all of the functions inside it that are repeatedly used by all these codes. So we've got the get sequences. This gets groups of sequences in storage folders called processing across all the different 12 storage devices that we have. And it organizes them into small batches of 2 and passes them on to the assessment script. I tried larger batches in Dagster, but I found that when one of them failed in the batch, they all failed. So what I've been trying to do instead is have smaller batches that launch more frequently within Dagster. Assessment is using the image sequence assessment. It extracts metadata, runs a media conch policy check against the first image, and checks whether it's suitable for raw cooked encoding. If it's not, it pushes it into a tar wrapping pipeline. It hands the sequences into the next 2 scripts, one of or the other. So transcoding. This runs the raw cooked FFE1 Matroska transcoding. It parallelizes encodings using Python's multi-processing pool module. I've moved away from GNU Parallel, I'm so sorry. It also runs validation checks afterwards that qualify if the Matroska's whole, and it passes media conch policies and that there are no errors in the logs. It finally then runs a raw cooked check pass, which we do. It is kind of duplicating because the all command also does the check pass, but it's a belts and braces. When we do it a second time, if it passes a second time, we'll delete the initial sequence. But it is time consuming, that part of it, I have to be honest. This is the archiving script, which runs the tar wrapping using Python's tar file module. Again, it's parallelized using multiprocessing module. An MD5 checksum manifest is created before we wrap the tar file. Then we open up the tar file after it's been tarred, read it back, and check it matches the manifestation. The MD5 checks the manifestation. And we then embed that MD5 manifest into the tar for long-term preservation. The transcoding retry, this is a single run script that senses when a raw cooked encoding has failed by identifying failed encodings from a database, which I'll show you in a second. It just runs all the same things as the transcoding. And so we have now a new development of an encoding database. I wanted to manage all the data within this workflow in one place. So I incorporated an SQLite database using Python's SQLite 3 module to communicate with it. All of the scripts read from or write to this database. So get sequences makes the first row for the file. It adds the file name and the file path. The assessment script then populates lots of metadata throughout that row and also like information about the sequence. And then the encoding and wrapping scripts add in information about the derivative, the FFV1 Matroska, including like an MD5 checksum and success and failure statements. So this is the new folder structure. It sits within image sequence processing now. We've got rid of DPX encoding because we also encode TIFF now. We're doing TIFF. We've got some DCDMs running through from our film operations teams. So the logs, we've got simplified logs so people know when they get into the image sequence processing, they can just dip into logs, look at the check logs from raw cooked, failures where things may have failed and get dumped into the failures folder. The logs will be in the failures log. TAR logs and transcode logs are for the two different encoding pipelines. If we have any failures, the sequence file and the encoded items will all get put to the failures folder for review so we can work out what's going wrong with them. All of the raw cooking is in the FFV1 transcoding folder, and then processing is where all of our colleagues drop their initial image sequence folders to begin the processing. TAR wrapping at the bottom. I've got a separate for deletion folder. That's just because sometimes I switch off deletions in the workflow, automated deletions, so that I can do reversibility testing. So if we upgrade FFmpeg or we upgrade raw cooked or we upgrade something in the operating system, I'm going to want to switch off deletions and then just do some localized reversibility testing. So that's why we have the extra for deletion folder. Wouldn't need it normally. So we've got 12 different storage locations in Dagster that these scripts need to run against. We just call the one set of scripts now, but each script runs against 12 targets. To get our single asset targeting all of those paths, created a workspace.yaml, which you can see here. In the document, we tell Dagster to load the workspace from repeat Python modules, all selecting our BFI Dagster project, which you can see. For each instance, we allocate a unique attribute, which is an attribute name, a location name. And then in the project definition script, there's a function called build project definitions, which is shown here, which loads each of our project defs on the left, linking environment variables containing the storage paths and initiating each of the script assets and sensors for every single path. We store our secret path environment in environmental variables on the server that's running this code. And here's the result when you load the workspaces. The deployment section of the Dagster UI shows all our code locations loaded into the Dagster workflow, ready to do lots of lovely work. At this point, I realized running multiple versions of the same asset across multiple storage would present a problem reading and writing to the database. So these assets will run in parallel, and I need to ensure that writing to the database from multiple scripts at once won't clash or break anything. This is when I needed to consult some experts for assistance. This was new to me. So I went first to the Dagster Slack channel and reached out to some people. Didn't get great results, I'll be honest, but I think that's because our workflows are quite unique in that they're media heavy. And then I went on the usual kind of channels. Dagster is a fairly new orchestrator compared to Airflow, so their documentation isn't that comprehensive yet. But in the end, I had to go to a large language model, I'm ashamed to admit. The BFI have a safe AI governance group, and the head of data and digital preservation, Stephen McConaughey, is a member of that. He made a case for our team to use a Poe subscription to pose questions to Claude, which at the time was the best LLM available. Poe integrates kind of LLMs and image generative AI projects into one website, which allows you to switch between models for your questions. I've got very mixed feelings about LLMs, I'll be honest, and AI. I try not to use them unless I really have a problem I can't resolve, like with Stack Overflow or actually speaking to humans. I know LLMs are very much more energy hungry than regular web services, and I've heard that water usage for every question you ask is between 0.5 and 1 litre, and that's horrifying. But for the help completing this project, Claude really provided invaluable information. So for my own ethical reasons, I wanted to learn how to use the LLM as efficiently as I could. Sadly, this very long conversation is an illustration of me getting it wrong at the beginning. Lots and lots of circular chats with the bot, kind of constantly introducing errors to the code, circling back around, making mistakes. It was a bit of a mess at the beginning. But here's how it helped me. For my first issue, when building that multi-project version of Dagster, it helped me with the workflow YAML that I showed you earlier. But it also introduced me to a concept called factory functions, which I wasn't across. So every script has a factory function that allows reusability from different project paths while ensuring consistent asset behavior. So in the code example shown, the top function is a factory function that creates a Dagster asset. Rather than hard coding one specific asset, this function can generate different variations of the asset based on the optional key fix parameter, which comes in, and that is the thing that points to the different storage devices. Next, I wanted to make sure the read and write transactions from the database weren't going to crash, basically. I was seeing SQLite concurrency errors when I first started running a couple of different path workflows at once. The LLM introduced me to something called write-ahead logging. In SQLite, it's a journaling mode that improves performance and concurrency in database communications. So when you enable this mode, SQLite writes changes to a separate log file before applying them into the main database. And readers can maintain access to that database while not being blocked by the writing elements. So when you enable write-ahead logging mode, you get 2 additional files that are created alongside your database.db in the top left. So the -wow file, this stores the changes made during transactions. It acts as a log of all write operations. The changes in this file can be applied to the main database during what we call a checkpoint call to the database, which you make whenever you kind of write extra information. Then the -shm is a shared memory file used for inter-process communications. So it allows multiple database connections to coordinate access to that write-ahead logging. It keeps track of processes that are reading and writing to the write-ahead logging at that time. On the right is some of the Poe conversation again that helped build the code on the left and integrate it into the script assets. So my last tricky question was about parallel encoding. Using Python's multi-processing pool operator, I had to go at importing it myself, then consulted Claude when I started getting a few errors that I couldn't resolve. The conversation on the left discusses how to import parallel executors to parallelize raw-cooked encoding. This was one of the first horrible long circular conversations when I discovered that LLMs can have a very short memory and will repeat their bad advice to you despite you saying, no, I don't need that advice. Eventually, it helped build a very simple resource, which is shown at the top right. And one little line there at the bottom initiates the processing pool resource in the code when needed for either encoding raw cooked or tar wrapping. And yes, sometimes it randomly answers in a different question, which is probably not a problem for all of you in the room, but for me it is, I'm afraid. My main takeaways when using LLMs is keep your questions specific and detailed. Don't pass in any secret information or cultural data. General questions get a lot of misinformation that may not relate to you and irrelevant data that can break your code quite a lot. Asking too many questions in one chat window as well is often an issue because the LLM then starts to circle back to that bad advice. So it's quite good to ditch one window and then refresh and start in the next. After a lot of chasing around in circles, I realized the best method is also to share your own code with it. So write something yourself first, give it something tangible, and then ask it to do one thing and then implement one thing. So, and my own personal preference, which is stupid really, but I like to be very polite with them because at some point they are going to get embodied. So, the code is now live and in our open source repository. The code for the workflow sits in this BFI Dagster project folder. Let me get that going. There we go, this project. The cron code is actually a few of the old scripts from the original workflows that we're carrying over, and that's the unwrapping scripts. I've been able to do some UI kind of one of this is a visualizations folder, sorry, for my colleagues to use. That makes the workflows more transparent for them and for me. And then in here, we've got our media conch policies. And in this one, we have a new Streamlit app, which I just made before I came here for a bit of fun, really, to see what kind of information I could get out of the workflow. Now, I launched it in April, so it's 6 months in, and I just wanted to see what kind of data I could get from it. This is one of our media conch policies as well, the new TIFF sequence policy that we've added to the repository, and they're all available there for free if anybody would like to have a look at them. So this is a direct acyclical graph, which is central to kind of orchestration work. It's a workflow asset lineage, and it's for our BFI project number 4, which is just one of our different storage devices. It's a simplified workflow and a pretty uncomplicated graph for us that runs all of our raw cooking. Resources in Dagster are external dependencies that your script needs to perform their function. This can include your database or an API or just a file system. Resources are defined in Dagster code and are passed to the tasks that require them. Assets represent the outputs or materialized data from your workflows. It's showing code here because the code is what builds the assets. Then we have schedulers and sensors. Dagster includes built-in scheduling capabilities. It's very easy now for me to turn off a specific path just by going to the jobs and switching a button. And this is the Dagster visualization of runtimes. It's so helpful for the developer team. From here, we can inquire about runs against different storage devices. Successful runs showing green. Their length indicates the total duration of multiple processes that are running against the one storage. You can click on any of these and go in and have a look at the jobs. The red block here is a failure, which is so obvious and clear now. It's wonderful. We literally just click on it, have a look at where which of the actual assets has failed, and then down here we've got a view full message at the bottom, which opens up the Python for us to show us the exception that's been raised and where the problem lies within the code. It's such a transformational difference for us. And one really exciting development, and a thank you to some people here in the room, we've finally got, the first time I've ever had voluntary contributors to one of our repositories, and Rito is one of those. Thank you very much, Rito. It's really exciting. It's a special moment to have other people help out on your project. So this is, very quickly, the UI that I've installed now we have that database that's maintaining all of the information for the project. We have this UI for our colleagues to look at, and they are thrilled. They really love to be able to see what's happening as it's happening throughout their workflows. We've had 468 already. Okay, thank you. I'm going to be right to time, I'm afraid. Yeah. So there are search options at the top for them to use, so they can really filter down on the information. We've got lots of metadata and stuff in there. And then we've also got error messages. So there's an error message column when there's a fault within any of the workflow pipelines, and they can take a look, read what the error is, and we've got some online documentation for them that helps them action their kind of recovery responses. And this is one of the examples, 223 gaps in the error message. What I started to do while I was testing the workflow was build in a little refresh option for myself so that I could easily refresh the database, which would relaunch testing. I then realized that would be useful for colleagues. So it's expanded now to have a number of different options that our film operations teams and media operations teams can use. So they can refresh a sequence if something's gone wrong. They can accept gaps, which will actually flag in the database and then pass through to the assets to use the accept gaps flag within raw cooked. We had in testing some DPXs with a frame rate of 1 frame per second, which made insane FFV1 Matroska files. So we've also got options for them to force the frame rates of the FFV1 Matroskas as well to something more acceptable. And very quickly, this is the Streamlit project. Streamlit's been made by a guy called Simon Willison. It's an open source Python framework that allows users to create and share web dashboards with very little Python code. This is just a little bit of a project to visualize what we've done in the last 6 months. So the left graph is sequence by sequence, and the red is the saved terabytes of space. The blue represents the original source file size, and the yellow is the FFV1 size. It does show us very quickly that some of our projects are like 4.5 terabytes in size, some of the reels that are going through, but none of the FFV1s are larger than 2 terabytes. The pie chart on the right is a lovely overview of how much storage space the DPXs and the TIFFs represent, how much they are afterwards in yellow, and the red is all the savings for this 6 months. So that's 467 items, and I think we've saved about 149 terabytes of space. So zooming in, you can get some really good details about it. This is available for free on, for open source on our, and free on our repository, and you're more than welcome to take a look and maybe implement something for yourself. In time, I hope to do a bit more with the Streamlit for our own visualization. Okay, sorry, I rushed through that a bit at the end. Thank you very much.
That was amazing. You can see and talk with Joanna, and if you have questions afterwards, or do what Redo did and go on GitHub and contribute.
Please do. Thank you very much.
So as we transition, I'll introduce the next presentation. We have Building AV Specs with Eddie Colleton and Blake McDowell.
Hi, dongle maintenance. Bear with me.
Technology. How's everyone doing? Yeah.
There we go. Unplug and replug. Still nothing? Cool. Hey!
Yee. All right. So again, we have Building AV Specs with Eddie Colleton and Blake McDowell.
Yes, there we go. Nope, you're okay. Oh, because this isn't connected to the internet, that's why. Do you want to do mid-presentation swap? Okay. We can just swap. Okay. Yeah, I think he just uploaded it.
Small chance that we could grab the Ethernet from here.
Okay.
If you think that might work. Is it this computer needs it?
Yeah. I mean, yeah, that'll work. Let's see.
Well, as we troubleshoot, if maybe there's a question, just letting you, for Joanna, just letting you know, we might cut you off though, once it gets set up. No, it was clear. Everyone's got to contribute to the repo now.
Okay.
Yeah.
Hi. Awesome. Very interesting. Thank you. And yes, very good to be scared about LLMs for a good reason. Have you ever tried like local setups of LLMs for coding assistance? Yeah, like your own machine.
Not training your model. Let's do. Are you okay? Yeah, as long as you don't mind me swapping.
No, is the short answer. No, I'm sorry, I don't. No, just Poe so far. I think you need to tell everybody.
Next year's no time to wait.
Sweet. So you can see. Sweet. Oh.
Yay.
Sorry about that. Hi, I'm Blake McDowell. I'm the media archivist and conservator at the Smithsonian National Museum of African American History and Culture. But the federal government is currently shut down, so I am not here officially representing the Smithsonian in any way, shape, or form. Just want to be clear about that. But I do want to quickly give an introduction to this project that then Eddie's going to give a very much better presentation on. But it's something that we collaborate with the Getty Research Institute in LA. Together, the museum, NMAC, and the Getty steward the Johnson Publishing Company archive, which is one of the most significant archives of Black American life in the world, and consists of approximately 4 million photographs, 5,000 magazines, and 10,500 audiovisual recordings, and 200 boxes of business records. And what this talk is focused on is the 10,500 audiovisual recordings, about 8,500 which are magnetic tape video. So Getty's provided approximately $30 million to do this project from 2019 through 2029. And of the videos, it is largely the production elements and final shows of their roughly 10-year series, the Ebony Jet Celebrity Showcase, plus other stuff from the Fashion Fair and the American Black Achievement Awards. And there is David Soul, who works for the company Media Burn, which some of you may know, based in Chicago, which is where the archive is right now. So it's in a warehouse in Chicago, and that's his little lab that we built for him to do at least portions of the digitization. But with that large number of tapes, we knew we were going to have to do a lot of outside vendor work, shipping tapes to vendors, and we needed and wanted a more robust tool for doing video QC. And so I reached out to Eddie, and he developed AV Specs, so I'll pass it over to him. Let me just unplug this now.
I want to be able to show you the app, so that's why we're doing all the computer switching. Thanks for your patience. I'm going to try to wing it, but I will inevitably panic and open up the PowerPoint, so when I do that, that's what's happening. That's why I'm doing that. It's because I got too nervous. Okay. So this is AV Specs. There's a blink and you miss it dependency check. So if you missed it, you blinked. The logo at the top is an homage to a punk band that I like called X-Ray Specs. And so as Blake said, the application is no longer visible on the screen. Okay. Just can't breathe on it. AV Specs is a Mac OS application that's written in Python for NMAC to process digital video made from analog sources. Can't get to the Wi-Fi. In practice, the user will import a directory. And the directory needs to contain an MKV file that has the same name as the directory. So this is one of the many ways in which the app was made specifically for NMAC's purposes. We've been developing it for 2 years, and we've been very focused on their needs. In our 3rd year, we're hoping to make the tool more interoperable and a lot more intuitive for folks who aren't using NMAC's very specific workflows. Just gonna have it run in the background while I talk. So once you import the directory on the Import tab, you can select which tools you're going to use on the Checks tab. So we can make the whole file MD5, which I just learned is the worst option. So we'll be adding more cryptographic algorithms soon. It can also use FFmpeg's stream fixity functions to create an MD5 for the audio stream and the video stream. NMAC embeds metadata into their MKV files, so we want to be able to validate if the whole file checksum is changed, has the video data changed, or is it just the metadata? This HDMI cable hates me. Good. And then there's lots of metadata tools that our audience is already familiar with. ExifTool, FFPro, Media Info, Media Trace for checking that embedded metadata, and QC tools, MediaConk, and I'll discuss QC dparse in a moment. You'll see that each of these tools has a run tool option and a check tool option. The run tool option is hopefully self-explanatory. It runs the tool on the input video and creates a sidecar file in JSON. And then the check tool references the specs tab, which is over here. And the specs tab holds expected values. So it takes those JSON files that it just made and it says, is the expected value the same or is it different? So if a match is a pass and a mismatch is a fail. Very similar to MediaConk. So if you've used MediaConk, same basic idea. You can have multiple values. So Namak uses both FLAC audio encoding and PCM encoding. So rather than having two separate policies, it can accept multiple values. These are customizable in a sort of manual way. You can export the specs config as a JSON file, edit it to what you want, and then import it. But we're working on, in the next year, should the government ever reopen, making a more GUI-friendly dialog window. So the first one we started with is the file names. So let's say your file naming convention is no time to wait, NTTW, good. Then a underscore, and then any 3 letters, and an underscore, and let's say any 3 numbers. So then this will use this as like a file name checker. Again, it would need to be both the folder name and the file name for now. Or you can use like a true wildcard, right? Like just with the asterisks. Or if you know the regex, you can just put the regex right in there. Okay. So this is the thing I'm most excited to talk to you guys about, is we've incorporated a AMIA, Association of Moving Image Archivists, open source tool called QCTparse, which parses QC Tools XML, hence the name, that was developed by Morgan Morell and Brendan Coates in, I forgot the year, and then was sort of like, not deprecated necessarily, but it was written in Python 2 and not maintained. So we've built that in. This is not a dependency. So everything like media info, QC tools, all that stuff need to be accessible through the path for the app to be able to use them. You can still use the app if you don't have all of those installed, but you'll get errors if you try to use FFmpeg and you don't have it installed. QCTparse, however, is built straight into AV specs, so there's no underlying dependency for that. The way that we're using it at Namak is that it will detect color bars at the beginning of the video if it has them, using a handful of conditionals for QC tools signal stats tags. So if the Ymin and Ymax and Ydiff and I think it's SAPmax are all of a certain, above certain thresholds or under certain thresholds, it will identify those as color bars. And then it will give you like information about the YUV and the SAT thresholds. It averages them, the mean for those for the color bars, and then it uses those means as thresholds for the rest of the content. So let me show you, and it collects this in an HTML report, which hopefully will open and not break the computer. There we go. So these are all the results. So you have the, again, apparently very costly checksum there at the top of the MD5, and then the MediaConk results in a little HTML table. I hate HTML. And then there's the differences between the expected and actual values are collected there. And then here's all the QCTparse stuff that I was just talking about. So there's the color bars, and there's compared the tape content compared to the SMPTE color bars. And then here's the content compared to the thresholds established by the color bars. So our Y maximum is a little bit higher than it is in the color bars. And I'm proud of this. You can click on it and make the image bigger. that took longer than I'd like to admit. And this is where, in addition to, oh no, oof, in addition to making the tool like more interoperable and like, for instance, working in a Windows environment, where the other area that we're going to be focused on in development is expanding on this. So I will go back to the presentation, not out of fear, but just out of, because I have one picture I want to show you. There we go. Where we're using Python's OpenCV library to identify the blanking periods that we're seeing on the left and right sides of the frame and the head switching artifact that we're seeing on the bottom, because QC tools information's at the frame level. So we were getting lots of frames that were being reported as having like values outside of broadcast range, and then during manual QC, you'd go and look and it's just the borders, basically, right? Just the blanking areas on the side. So we're trying to, that's sort of a next step of development, is to automate some of that QC steps so that it can flag issues that are actually in the picture area and not outside of it. I'm sure I went too fast, I forgot something, but it leaves more time for questions, I guess. Yeah, please do download we have a user base of like 5 people right now. So if you have Mac OS and you use some of these applications, please give it a try. It will probably break. So report that in GitHub issues and then I can fix it. We have, don't use Homebrew. GitHub Actions changed something on me in the last like 2 weeks. It's bad timing. I think that's it. Well, like I said, we have 1 more year of, assuming that there is a United States government for the next year or whatever. One of the many things that will happen if the government doesn't reopen is that the app won't get finished, along with a lot of other things. But we have 1 more year of that, and then we're looking for other folks to jump in and to continue funding development. So again, that's sort of our goal of like building the user base so more people can try it and maybe pay me. Okay, that's it. Thank you for your time and attention.
You did great. We're back on time. We have so much time for questions now. If anyone has questions, not government related, please.
Hi. Really cool. And I didn't see any Mac specific libraries or usage, so how hard would it be to port it to Linux?
Oh, Linux. Unknown, but good idea.
Python, all these tools are cross-platforms. Like, I know all these tools, I use them on Linux. So basically, I may hop over there quite quickly, unless you say there's this specific library that's like dependency.
The GUI is PyQt6.
So
should be fine.
Right.
Nothing's jumping to mind, but let's work on it.
This makes me very happy to hear. Thank you.
Yeah, cool.
Yeah.
Linux, good idea.
You might have someone joining in the GitHub.
See you on GitHub.
Questions? Yes.
Thank you. I will definitely become a user. This is amazing. So cool. I love the aesthetics as well. My question is related to amateur video and video without color bars or standardized recording information. And I'm wondering what the system can do to handle videos without color bar.
Yeah, that's a good question. So the open source version of QCT parse, which still works as a standalone tool, when I updated it to Python 3, I also updated the EMEA open source page. That allows you to use user-specified thresholds. So you can just say, let me know over this value. That also lets you use profiles. So you could say, for this set of tags, use this set of thresholds. But building it into the GUI was getting really complicated because it could be greater than or less than, and Mach wasn't using it. And they're paying for it. So that's, so it uses stuff that they needed. So as of right now, it's not built into AV specs that you can specify that stuff, but that's something that we're looking to build into as we do more of this automated QC stuff. There'll be a little bit more room in the GUI. I've added a complex tab, so now there's checks, specs, complex. So anyway, there'll be more room, then maybe it'll be easier for user-specified thresholds. But that's good to know that there's interest there.
Okay, one more question.
I will let you know that building a Qt app for non-KDE Linux is absolutely miserable because you have to get the KDE dependencies in there, unlike on Windows or Mac where Qt libraries are standalone. Having said that, I'm curious how you're doing your code signing for Python, Mac, desktop binaries, because I know that's really, really annoying, having done it in the past. There's not a lot of documentation on that, and I think that's often a limiting factor for building GUI tools on Mac.
Yeah, I hate it. It's awful. I don't really like anything about GUIs, as I've learned. This is my baby's first GUI, and I don't like them. But the code signing is done in GitHub Actions, and so they have a lot of resources on GitHub for figuring that out, but they're all super confusing and convoluted. So a miserable trial and error, unfortunately, was my process. It took me a week. I'm sure that I ran, the workflow run count is in there. I wish it wasn't, but it's probably over 100 or something like that. And then, and I also, echoing Joanna's comments, I, to my shame, used Claude to help me troubleshoot it, burning down the rainforest or whatever. But I couldn't figure it out otherwise, so I used that.
Okay, one last question.
As someone who hates GUIs, are you thinking about doing a CLI version of this that would kind of you could feed in some of the output data?
Yeah, it started as a CLI app, and still, although it gets less testing than the GUIs, should still work as a CLI app. So you can just run AV specs and drop the input directory into the command line, and you can edit all of the GUIs can relate to JSON configs that are in the application support directory, and there's flags to edit the configs, or you could manually edit the configs as well. So you could, yes.
Okay, thank you. We technically have time for more conversation afterwards, but we're gonna cut for a moment because we're gonna fix some technical difficulties. Yay, thank you.
Thanks, everybody.
Okay, hello. Last one before lunch. Yay! No pressure though. So, very excited for this next one of introducing JSON ID with Ross Spencer. And I'm going to hand over the mic so you can walk and talk.
It's not so much walk and talk, it's just crazy energy. So thank you, everyone. This is my first time to introduce JSON ID here at No Time to Wait. It's a project I've been working on since January. The too long didn't read is that JSON ID is a new approach for file format identification of JSON, YAML, and TOML. It's a declarative approach. It plugs gaps in program in the way Pronom and Droid and Siegfried does things, but it's complementary. Hopefully, what I'll be able to do is output Pronom signatures from this tool. And when I use the word registry in this presentation, it's with a lowercase r. That registry needs to exist somewhere that's not my GitHub. Ideally, it is actually Pronom, but it could also be Wikibase or Wikidata. We get encoding and white space agnostic identification, deterministic identification of JSON, YAML and TOML, which is a little difficult in Droid. It's not impossible. We have new technical characteristics for these formats, or at least we've combined technical characteristics that you can find in other areas and other tools into one, and we get universal fingerprinting, so like checksums, but for identical data. I wanted to start with a pop quiz, but I'll save everyone the actual interactivity of that, and just hypothetically, are these all the same? And the answer is, so in the middle here, we have a hexadecimal representation of JSON, and on the right-hand side, we have the actual JSON itself. And they're not really the same. There's some extra spaces included in the first three, and in the last two, they're actually just two different encodings, one using little endian encoding, one using big endian encoding. And these are small areas where tools like Pronom can trip up. But we have effective ways, we're going to find out, effective ways of actually just ignoring this completely. Pop quiz 2, are these the same? And the answer is, of course they're not. There are three different document types, JSON, YAML, and TOML, but also they are exactly the same as each other. They're examples of SERDE, serialization, deserialization formats, serialization from data structure on disk in memory onto disk, deserialization from disk onto memory. In memory, we have exactly the same data structures that we use for all three of these examples, and they look something like this. Two examples, one in Golang, one in Python. The Python's probably the easiest to look at because it kind of looks the most natural of the JSON that we've been looking at here. We have a list of, three keys, values, hello and goodbye. We have a list containing an integer, two integers and a float, a string world and a Boolean false. And yeah, it's cool. You know, once you start looking at the world through these eyes, you start thinking about your formats differently. So we also have all, I'm not going to do an Eric Morecambe voice, but we have all the same data, just not exactly the same order. So when we have data structures like we've seen, we can also have all of the data in a different order, and it's actually still all the same. Yeah, sure, there's a way we look at this world with MD5 and say, no, they're all different. And when we receive them, they're going to be all different. But there is a way to talk about these as equivalent formats and equivalent data. It's all data structures all the way down, possibly by Bertrand Russell. And it's not all biostreams are equal, but some are more equal than others. So before I go on, I want to say thanks, Kieran. Part of the reason I'm here is I did happen to make this tool, and last year he asked, when I was talking about declarative programming, had I ever done it in my digital preservation work? And the answer was no, but I had written a declarative language in key value access language to handle some of the boilerplate stuff around accessing key value stores. But now JSON ID exists, I thought I'd say, well, I've now done it in digital preservation, so I have a declarative programming language for JSON ID. So thanks, Kieran. And what does it look like? Well, we have instructions like any other programming language. This is probably non-exhaustive, and I'm not even sure I'm using all of them yet. I encoded them all, and I've written tests for all of them. But as I develop a corpus of data around this, I find out more and more about what is actually needed. They get combined into a list, and you can see the instructions are combined into a list that also looks very JSON-like. We have, in all of these examples, we have an instruction to find a key, and then we say something like, is this value, or contains some value, or is, again, some other value. And in this case, the some other value here is looking for more JSON-like data. We can also look for things like data types and so on. I've managed to put together an example of 80 signatures using this approach over the course of probably about 3 months rather than the full half of the year. That's one of the benefits of using the declarative approach. You can find this in a registry here. There's links at the end on a QR code if anyone wants. I've got integration files, so the files I've been using to develop this corpus as well. And so what does it get us? Back to TLDR, it gets us an ambiguous identification of these formats. We get encoding agnostic identification, white space agnostic identification. I'll skip through some of the rest. And we get significant properties. But we don't really talk about significant properties. We call them technical characteristics, or in this sort of very non-deterministic world of digital preservation, more likely just clues that might help us to look after our content better in the future. And so as I've been developing this tool and developing the knowledge behind this tool, I've just tried to bring together a couple of different artifacts that are technical properties together into one that might be useful. Things like long line warning here just tells us if a JSON file is likely to be one single line, which is difficult to handle in memory for some text editors. We talk about the different key types, whether lists contain different data types, because when you loop through those, they're going to cause different errors unless you handle them properly. And we've got the fingerprinting here, which I'm most excited by. So we've got all the same data, and in the sort of, you go to digital preservation school today, you're going to find out they're still all different. They've all got like different MD5s. So you're going to treat them differently, you're going to look after them differently, and you're never going to connect these automatically like this unless you actually look at it. But what if we put them together and said, what does the data say? And the data says we can give these 3 examples here all the same fingerprint because they contain all of the same data in memory. And so borrowing from Dataverse, I've added the universal numerical fingerprint to the output of this tool, and borrowing from the world of interplanetary linked data. Sorry, another swear word. Linked data is not so popular anymore. But interplanetary linked data has this interesting concept of a content identifier, which is a content addressable identifier, which allows you to basically unambiguously identify JSON-like data types in that world. So we can say, using this, we can automate the identification of same as links between, let's just say, the 6 examples or more in this presentation. We can start to say they're all the same as each other. So does anyone know what these are? No hands? What, they are space invaders, but it's a street artist called Invader from Paris. I just wanted to talk about the sort of the intent to collect, the things you get when you collect, or deciding not to collect. And this is the first one of these I saw in 2006, probably just after it's put up when I moved to London. I started collecting them in 2000, like this January actually, same time I started writing the tool. And now I've managed to catch 179 across places like Paris and Vienna, and the space station. And yeah, there's a lot of benefits to collect. So anyone who's like never collected the thing they wanted to collect, whether it's matchbooks, stamps, bottle tops, or whatever, I'm one of those. Like, there's a couple of things there that I sort of wish I'd still had or collected more of along the way. But like, and in terms of digital preservation, I think we've always had discussions about, do we collect JSON schemas, XML schemas, put them in a database and do something with them? And I sort of just never got around to it, like, until now. And so I did. And in the last year, I've got 80 examples in the JSON ID registry. Be great if other people would want to add to that. It's on GitHub. And then I found something interesting about collection, about network effect, where I expressed network effect in my last talk as something sort of more external and involving lots more people. But I found something internal as well, where like as I was collecting these, I was able to add to services like Wikidata or the Just Solve It problem and improve those through my own process of collecting and gaining knowledge. So I recommend people collect and do things. It's also fun to collect things. I found the iPuzzle format for encoding things like crosswords and word searches. That does exist. It is in JSON. Next steps. I want to support local rule sets for people who have like very institution-specific data, like research data and so on. Extend it to pronom. There's some improvements to the language I want to do. Make a Golang proof of concept. Maybe integrate it to Siegfried so that we've got identification all in one place. And a full article about some of these concepts and what they might mean to the community. Maybe rename it because we like cool names in this field. So like maybe Jason Statham or Jason Momoa or even Jason Donovan. What about Dolly Partommel? Before I go, you might have noticed I didn't reference the specification. So this comes back to, so I did a synthesis of this work for a team last year. And I'm not sure they appreciated the full sort of meaning behind it and sort of how much we could get out of some of the way of looking at this from not looking at it at the specification. Because if you think about it, I kind of have to combine at least 3 specifications here. But there's also a chicken and egg problem with this, where like most of the specifications came from programming languages anyway. And it's in the programming languages where you've got all of the messy stuff. You've got hole punches in floppy disks. You've got people doing crazy stuff with data structures, not even respecting the rules. But there's a way of looking at this from a programming perspective and saying, what can I do if I look at it from here instead of this sort of more academic specification side of things? I was a bit disappointed the team sort of didn't see the full, reach of the work when they said you didn't reference the specification. And I think important for beginners in this field, like people getting new to the field, and there are people here today new. I really didn't want to not lose that work, and I sort of wanted to own it for myself. And so I was like, I took all the work I did for that, and I thought, you know what, I'll write JSON ID. So welcome JSON ID. More existentially, thank you to No Time to Wait for providing another space for this work. I think I don't actually work in digital preservation as my primary job. I do a lot of this stuff in my spare time. I don't know why. No, we all know why, because we all think it's important. But I do find GLAM is a bit of an unhealthy field for career mobility. It's difficult for people to like change institutions that they're struggling with, or just find a position for them, like doing what they want to do and everything. And if you find yourself on the outside, it's difficult to get back in and share these stories. So for 2 years in a row now, No Time to Wait has been a bit of a third space for me. I also think it's a bit of a third space for other people here. So thank you for having me. Thank you for having this, allowing this talk. And Miller Boyakis. If you want more information about JSON ID and related stuff, use the QR code.
So since we're right before lunch, have your questions for Milos Ross after lunch. This is all you.
So just a few things on the lunch. I might have overblown the situation earlier. I think everything was fine for the break. It might get a little bit more jam this time, but one thing I really want to point out is we have a table in the back left corner that's got all the allergen and dietary restriction stuff. Like, please just leave that for the people who need it. In a true open source sense, when you get in, you can fork into 2 queues. You don't have to go straight down the middle. And just because it might get a bit jammed, just some of you maybe might want to stay on here and chat for a couple of minutes to let everyone else through, get some fresh air, go down and look at the AIDS exhibition. So I'll leave it there. Thank you.
Hello, hello. Welcome all. I hope we're all full, happy, hydrated. Just, it's Kieran's housekeeping rule, but I will remind everyone, water's okay, but tea, coffee, and the food that we just ate, not okay. So please, I will kick you out. How are we doing on the live stream? Perfect. Okay, so starting us off, now that we're all energized, is going to be Alex Garnett with FFV1 Hardware Encoding is here at last, experiments with NVIDIA GPUs and temporal.
Thank you so much. Hi, everyone. I am also, speaking of the last talk, no longer in DigiPrez full-time professionally. I'm doing something else for a living, but I have a lot of long-time interest in hardware encoding in particular, and luckily there was kind of an angle with my current employer to make this work out. So here we go. Let's talk about this table stakes for just getting into how hardware encoding works. We all love FFmpeg, Swiss Army knife. It's the Unix philosophy. If it went to go meditate in the jungle for 40 years, then came back and joined the French 75. That's a Pynchon reference. One guy laughed. Hell yeah. All right. Got him. Most FFmpeg encoders and decoders historically are CPU-based. You might not think about this. That means the video encoding is running in software on your CPU. It's not using hardware acceleration, which historically, for somewhat arbitrary reasons, means the parts of the computer that are not the CPU, i.e. the graphics card. FFmpeg also has some hardware-based encoders and decoders. Chances are you've never actually utilized them because a lot of the digital preservation workloads you're running will not direct you to do so. For example, you probably see X264 is the name of the CPU-based H.264 encoder in FFmpeg. I think the AV1 encoder that's CPU-based is called David, but it's like DAV1, kind of cute like that. All these encoders have their own names. They target specific codecs. If you're encoding H.264 FFmpeg with an NVIDIA GPU using the graphics card, there's actually something in there called H.264_NVENC for NV encoder. Uses a totally different set of parameters, different APIs internally. It's talking to the graphics card, so it's not really the same and doesn't share that many code paths with H.264. It just targets the same output. Hardware decoding has been around roughly since 2008 in consumer electronics. The reason why I think somebody mentioned earlier we're all still using H.264 as kind of the de facto access format is because that was the first very widely hardware decoded video format. That was the first one where we were scaling beyond what CPUs in devices at that time could do. And so when hardware decoding first became widespread, it was for everyone to watch H.264 720p, 1080p on their phones, on their laptops, which would have been much more difficult to do in CPU in real time at that time. So this is what made good asterisk quality streaming possible. Like you could complain about Netflix bit rates and like how their macro blocking is and their grain for all day long. I would love to do that personally. That's a really great use of an afternoon. But point of fact, however you feel about streaming bit rates, having H.264 support in hardware is what made that possible. And that's why your laptop wasn't going to overheat. Your phone wasn't going to overheat, get really warm when you were watching a YouTube video in like 2010. It is also why your Linux laptop probably did overheat in 2010 when watching that same video because the Chrome browser on Linux wasn't wired up to the GPU by default. They weren't enabling hardware decoding by default because of driver instability on the platform. And so, for example, that would run on the CPU. You'd be like, why does it slow down on this machine? It's using 75% of your CPU here, but not there. Okay. H.264 really needed that hardware decoding at that time. Whoops. I just pressed the wrong button. This is in a PowerPoint and not a Google slide, and it skipped ahead to the very end. Sorry about that. All right. Most devices that have that decode block can also do hardware encodes. It's not inherently symmetrical, but usually when you have that hardware, it does the same thing. Over time, this has grown from not just H.264, but also more recently, H.265, VP9, and AV1 are the four commercially popular codecs that you often see ship inside of commercial GPUs in your phone, in your computer, in your laptop, all kinds of set-top boxes like your smart TV. probably has about these 4 codecs that it can decode in a specialized hardware block, not in software. These are fixed function blocks, and actually I think that's a really interesting point to make that's going to be very relevant to this talk. This is not like the GPU doing like its 3D graphics muscle. This is actually a dedicated part of the GPU architecture that ships from the factory with the knowledge of how to handle a few separate codecs for encoding and decoding. And so it's not GPU software, it's not like 3D software per se, it historically hasn't been. It's a fixed function block in a GPU that knows about these codecs. Historically, this has not really moved the needle for preservation for a few reasons. One way I like to do a head check is to check what community standards are. For example, in the internet piracy community, they are very good at figuring out what looks best, what do I care about, and why, and then you kind of compare and contrast that with DigiPrez standards. If you look at the best practices guides followed by internet pirates, and you look at these scene encode, they write these, they're very good. The scene encodes of commercial movies uploaded to torrent sites. They all follow specific parameters that are shared among their community. They typically have an aversion to command line software because a lot of pirates aren't software developers themselves. So they'll usually use FFmpeg via Handbrake, which is a very popular GUI for ripping and transcoding media, but basically it's all FFmpeg. And what they're doing, they're always using the CPU-based encoders. Those will generally get you a better quality file, a smaller file size, preserve the film grain, higher bit rate. You'll get a better result for a preservation quality, a distribution quality master using CPU-based encoders. That's always been the case. So what's historically wrong with hardware encoders? With the exception of ProRes, which can be lossless, and that's a big part of it, they target relatively crappy baselines. If you look at like the profiles available when you're encoding to H.264, where it's like H.264, medium, low, high, you don't see that as often as you used to. But these hardware encoders don't target the highest possible quality H.264 file. If you look at an H.264 file from 15 years ago when they were first widely available versus now, we've actually gotten a lot better at making better encoders, mostly in software, because no one's updating the hardware encoder quite as often. ProRes is neat here because for a while, Apple actually made a standalone ProRes encoder card that you could plug into one of your Macs, and it was like a GPU that wasn't a GPU. It was like just for doing a hardware encoder for ProRes. So it was like a dedicated fixed function thing. I think that's all built into the M series computers now. So if you've got a new ARM-based MacBook, they can do ProRes in hardware. But these hardware encoders will give you lots of macro blocking, especially at lower bit rates. They are also much harder to parameterize. So if you're ever looking at the actual parameters you're giving FFmpeg for X264, the CPU encoder, versus H.264 NVEnc, it's a totally different set of parameters. They're two different sets of code paths. The software doesn't have that much in common. And this is a vendor API, right? This is NVIDIA's contribution to upstream FFmpeg telling you how to use their graphics card. It's not how do we implement the best community standard version of an H.264 encoder. It's NVIDIA's like, okay, we're gonna give you different parameters. So you can't use the same like quality ratio threshold that you can pass to a software encoder. And the options they give you are much harder to work with. I've often had to poke around in Stack Overflow threads to like find the one NVIDIA developer who actually works on the FFmpeg code base, whom I found, he's a really nice guy, and figure out exactly how to further parameterize that hardware encoder. They don't expose as many options. What they do typically, like what the hardware encode block is used for on most commercial GPUs is for things like Twitch, or for streaming like we're doing from right here, right? Because this way you're not putting on any additional load on the machine when you're sending a video from that same environment. It's a fixed function block, right? It's not the GPU, it's not the CPU, it's kind of a dedicated part of the GPU that's hived off. It might use some of the power consumption envelope, but it's not actually using any of the shader budget. Shaders are a way to refer to the GPU's like regular 3D compute muscle. So like a shader is what you can run on the GPU normally using that main 3D muscle it's got. Fixed function block is for video alone. And so usually this is a way to not leverage that shader hardware. To spare the shader hardware for 3D rendering, use a different part of the card. But that means they're computationally free. Your GPU fixed function block is historically over-provisioned. It doesn't need to encode video that often. Well, now we have Vulkan. When I was making this slide, I thought about putting like a Star Trek Vulkan because that would be more normal. But as a once and future nerd, I don't like to commodify nerd culture. So this is a Warhammer Vulkan. This is much less appealing, right? Like, you don't want to think about Warhammer right now. I do. Neat thing, Vulkan. Okay, Vulkan is a new graphics API. Historically, DirectX, OpenGL, older graphics APIs, up until about 5-10 years ago, mostly gave you low-level primitives for actually doing 3D rendering. They did not give you low enough level primitives to implement other things in the GPU. Vulkan is a more modern API that most people are now using for shader programming, for GPU programming, and it gives you lower level control over what you can make that GPU do, and that means what you can actually do is implement a video encoder and decoder in shaders using Vulkan. So now, rather than just being stuck with the fixed function hardware that ships on the GPU and only encodes and decodes commercially relevant codecs that the manufacturer actually wanted to bake in there, we can now essentially write hardware encoders in software, right? We can actually write software that runs on the GPU and does that encoding and decoding using the shader hardware of the graphics card, which you don't need for playing games because you're busy encoding video, so it doesn't matter that it's using a different part of the resourcing. And we have a lot more power here to now make hardware encoding actually versatile and actually customizable and configurable in a way that it hasn't historically been for the preservation community. This is really great for FFV1 specifically because it is not of commercial interest like H.264. So guess what the first, I believe the first, where's Jerome? I think the first, first Vulkan implemented encoder in FFmpeg is. Hey, it's FFV1, look at this. We are front page news, we are cool. People are making news stories about us. Yes! Never thought that would happen. FFmpeg's largest release yet, 8.0. This was very recent that it actually became available in a stable release. I think it may have been like last month or 2 months ago. The FFV1 Vulkan-based hardware encoder and decoder are now upstream in FFmpeg. So we can do hardware encoding and decoding of FFV1. That's super cool. You can actually click through, and I will click through if this mouse works, and take a look. Thank you, Microsoft. Can't reach this page. Never mind, I will not take a look, despite the Ethernet cable being plugged in. Oh, see? We have Wi-Fi 0, evidently. They promised me. Anyway, it doesn't matter that much. It's okay. So if you go and look at the FFmpeg repo and GitHub, you can see, like here it is, an FFV1 codec side by side with the others in hardware. This means it's not vendor specific. We don't have to implement using the NVIDIA or the AMD entry points. We can actually do it in a generic way that works on all GPUs. We have Media Area to thank for funding this work. It's now upstream in FFmpeg 8.0. This is awesome. If you have a not that recent FFmpeg build, you might have to get one that's actually got this work toggled on because it is new and uses a lot of experimental features. The syntax is a bit complex at the moment to do an FFV1 encode using FFmpeg. So if you've ever done X264, you got to pass it like Q level 23, very fast, very fine, whatever. It's like 6 arguments. This is more. This has a few more arguments presently. And to optimize this, I actually had to go into an FFmpeg bug tracker entry page because that was the only place I could find complete enough syntax for like really optimizing my FFV1 encode. And I wound up chatting with the developer who Media Area worked with to implement this and be like, hey, what's going on with all these parameters? One of my favorite things about FFmpeg, and it's hard to pick just one, is that it's actually overloaded the term placebo, where placebo means both the excessively slow encoding route, where it's like very slow / placebo, or here it means it's borrowing the tone mapping algorithms from MPV and using libplacebo to tone map based on YUV420p. This is not a de facto solution for encoding FFV1, but you can see what it looks like right now to try to optimize it pretty far. And I ran some tests. I've got a 4090. It's a very expensive GPU I don't need. It's a lot of fun to have. I have very fast storage. When you're running FFmpeg and you're trying to do a test with the GPU, you can check to make sure your storage and your CPU, neither of those are showing 100% utilization. That means you're not being bottlenecked by any other part of the machine, so you can be sure the GPU is doing all it can. I could not get my GPU over 40% utilization in my test, but I was using a relatively low resolution, low bitrate file, and so there's probably room for this to grow here. I couldn't find a bottleneck. I wasn't using all of my 4090 shaders, which are a lot and probably unnecessary in the first place. But if you do some math, 40% of a 4090 is like a 4070, and that card uses like 200 watts. So you can say I was using about 200 watts of GPU for these tests based on the ratios available. CPU-based FFV1 encoding is not fast. Jerome's probably going to check me on these numbers at some point, but like you can expect on about 100 watts of CPU to get about a half a real time with a large standard, a good quality file. I was averaging about 8x real time on most of the files I played with. That I think is output from a Bake Off episode that I pirated and had in my hard drive already. So like not the best source file. I have to do more tests, but it's really performant. And so if you care about energy, right? I heard a lot of people talking about the water utilization of AI today. Like this is actually potentially better for energy. It also gets you much higher throughput. No time to wait, right? We got to speed things up here. So I'm here from Temporal, which is my employer, and we make an orchestrator, a durable execution system. We heard a lot about orchestrators this morning, right? A lot of us in digital preservation use different orchestration workflows to run things from point A to point B and try to get good hooks, observability, reliability, and so on. Temporal pioneered a system called durable execution, which basically means your code will never fail and return when you don't expect it to. We run your jobs, we'll retry from any failure, that way you can go in and rescue them with a new deploy, you get hooks into where things fail, so that way you don't have to always restart long encoding jobs, for example, or lose the results of any work that we're already running. We get you distributed systems out of the box. We're a commercial open source platform, we've got a dev server built into our command line client, so we're super easy to architect on top of. We've got a cloud product offering, so the command line client runs SQLite, but our cloud product offering runs Cassandra, right? So you can pay for it or you can run it yourself. We hook into Grafana, all the stuff you want around reverts, retries, replays, we build that in at the table stakes level. DigiPres uses a lot of different workflow engines. I've worked with Archivematica quite a bit in the past, and you hear a lot about Airflow, Gearman, Celery, Sidekick. We all have to queue and monitor all these jobs, and no, we do not like to do that. None of our orchestrators work that well. They don't give us all the observability hooks, the retriability for our long-running jobs that we would like a lot of the time. Temporal is really nice if your whole life is queues and Saga patterns and error statuses. If you think about queues and flows way too much, it's a really nice product. And all of our SDKs, which are Python, Java, Go, TypeScript, Ruby, .NET, Swift, I forgot one, all just use protobufs over gRPC. So we're super cross-compatible. We are polyglot. We support a number of different use cases, really good for introspection and portability. Here's what our web UI looks like. You can monitor the different activities run by a given workflow and add in different hooks at different points in time. You can see all your workers that are distributing your state. It's really neat. And I made a little prototype using FFmpeg to put my money where my mouth was, and this is an example written in Go that uses a feature of Temporal called heartbeating, so that I'm actually redirecting standard out from FFmpeg over the course of a login code and reporting it back to my orchestrator, so that if my encode failed from whatever reason, I would have a last offset to resume from, and I would also know immediately when that encode failed. It would surface an error, but it wouldn't necessarily fail out. I could redeploy, retry from there. Lots of fun stuff. So, fail fast, fail often, automatically retry. What does this mean for you? Well, anecdotally, Temporal is being used for commercial video encode pipelines at, for example, streaming media providers that have to generate many different derivatives at different resolutions of their content. The Demux community, which is like a more commercial but still open sourcey take on video encoding, is probably also interested here in this kind of work. I like to get communities talking. That's why I'm reading these piracy best practices manuals. That's why I'm here. That's why I'm telling my employers, no, I swear it's a really high value conference, right? It's nice to figure out how the other side lives every now and then, and I think this is a really nice generalizable approach to video encoding, thinking about how we use the hardware we already have and the hardware that we might want. Temporal can scale in ways that GPRS often struggles with or does not really take for granted. For you personally, good news, you can now expense a $2,000 GPU. I think, that's often the subtext here. It's admit it, you just want to play Battlefield. It's I think subtext is for cowards, the subtext is text. The new Silent Hill is very good. Get a GPU, somebody will pay for it. Have them watch this talk. No, really, do it. But also consider adopting Temporal to help parallelize your workflows. We give you a lot of power over running multiple jobs concurrently, over time, hooking in, being able to get better insight into how your encodes, hardware or not, are running and how they are distributed. So, thank you very much.
That was perfect timing because I was going to give you your 5-minute mark. Questions, and yes, hands like shoot up right now.
So thank you for the presentation. Very nice. Could you go back to one of your first slides, please? And don't worry, I not talk about the stability of FFmpeg releases.
Which slide was this? I'm going backwards slowly.
Yeah, back. Yeah, one more, I think. Yes. No, one more. Sorry.
More.
Yeah, this was, sorry, hardware decoding. This was it.
Yeah.
Sorry. Can you give me one more? Okay. So you said that every new codec needed more power for decoding than the one before.
Historically, that's mostly true.
No. So yes, everybody says this, and you can kind of show it, but it's actually for the same quality and the same resolution. So far, every new codec needed less power than the one before. But since people want more quality and higher resolution, that's why it looks as if the new decoders are less efficient than the past ones.
Right. One of the reasons that H.265 was popularized was to support 4K resolutions, which H.264 could do, but it could not do at an acceptable file size level.
So because there was a very long presentation by a much more accomplished developer who showed that it's as it's worded here, it's not 100% true. So far, every new decoder was a bit more efficient than the ones before, but unfortunately, this was of course only true for same resolution, same quality. Sorry.
Oh, that's okay. And I think I was only kind of generalizing from like MPEG-2 and X, like the CPU common decoding use cases before we got to H.264.
I'm expecting a panel from both of you now. Any questions online?
Could you possibly explain how you use shaders for this? I mean, you have not developed the hardware acceleration, but you seem you understand how it moved to shaders.
Right, so just the fact that it uses the shader hardware is essentially what is the operative thing that's changed here, because the fixed function encoders were in a dedicated video encode block. And now that we can actually write encoders that utilize the Vulkan APIs, that's utilizing the shader hardware of the GPU.
But why you said that now it needed Vulkan to be able to utilize the shader, but the shaders were in the GPUs before. Why couldn't you use them before without Vulkan? I thought this was just like a level of API. You could go like to different hardware.
Yes, that's true, but it was very inaccessible. And so like previous 3D APIs did not provide the tools to do this very easily.
Accessible meaning the syntax?
The middleware level, like so I mean, early DirectX, early OpenGL, like they were implemented very differently across vendors, right? If you would have some like OpenGL 3.1 conformance test, it would behave totally differently on NVIDIA versus AMD. Like these APIs were pretty loose, frankly, and it was up to the vendor. Right, yeah, like the hardware software level was not very tightly coupled until fairly recently. Yeah.
Your Warhammer Vulkan was too aggressive.
Yeah, he was, yeah.
Always got to go with Spock. Okay. For the sake of time, we're going to start switching over. Alex, thank you so much. And as we switch over, I'm going to ask Libby to come up. Tape as we know it, and I don't feel fine. by Brianna Toth and Libby Hoppoff. Take it away.
Yeah, hello everyone. Sorry. Yeah, I'm Libby Hoppoff, and this is Brianna, and we are the co-chairs of the newishly formed Magnetic Media Crisis Committee. And just since we have such a small amount of time, really quickly, I'm just going to let you know what we're going to run through. We're going to talk very briefly. I know we all know a lot about the magnetic media crisis, but just to sort of talk about how we got here, the community of preservation workers, the impacts that this has had on open source tools, and the community, the committee, and like what we're up to as a committee. And I'll turn it over to Brianna. Yes. Yes.
Okay. So, thanks for hanging in there with us, guys. So I don't think anyone here is surprised that kids are progressively deteriorating due to a multiplicity of factors, which endanger their ability to be transferred, allowing the content on them to be preserved. The issue of magnetic...
We're getting you a mic.
Amazing.
Wait.
Can you angle the screen down? The other screen up.
Oh. Oh.
Yes. Perfect. We can do this. Also, thank you so much for accommodating me. I really wish I could be there in person and see everybody, but plans changed last minute due to a government shutdown, unfortunately. So, but I'm glad I can virtually see all of you. Anyway, so yeah, we all are very aware what the magnetic media crisis is. And basically, this is not new news. People have been advocating and talking about this since the 1980s. I'm not going to bore you with the textbook definition of what sticky shed syndrome is, since we can all agree that the combination of obsolescence and degradation related to magnetic media is a serious unresolved issue that many of us grapple with in our daily work. What I do think is different as we near the conclusion of 2025 is the scale and complexity of the situation, as factors impacting the magnetic media crisis have accelerated and multiplied. One point that we, Libby and I, the committee would like to put forth is that we believe the countdown for migrating magnetic media has started to conclude. Next slide. Various studies and reports, probably some of the people here have worked on some of them, have provided multiple dates within a somewhat alarmist narrative to advocate for greater support and awareness. And if these reports are to be believed, the time frame we are now working with, which has shifted slightly later, is somewhere between 2027 and 2032. So I think for us, that's relatively soon. Next slide. One of the motivations for forming the Magnetic Media Crisis Committee was that many of us have noticed changes in our workflows related to magnetic tapes over the last 3 to 5 years. Some of the primary workflows that have needed revision and are now monitored closely for updates have been baking, cleaning, and remediation procedures performed prior to transfer. Formats such as Dmatic, which previously only needed baking on an as-needed basis, are now regularly baked or baked much more frequently due to the current format's deterioration and age. Minimizing necessary wear to prevent damage on playback decks from these sticky tapes is also a consideration. Next slide.
Oh, this one's me. All right.
That's you.
Thank you, Brianna. For example, this is this is a diagram of how Meepop's, the place where I work, the baking procedures have changed over the years. Our original method worked all right, but the results were really inconsistent. We conducted research, reached out to colleagues, performed experiments to make some major changes in 2017, the biggest of which being removing the tapes from the shells prior to baking, and as well as increasing the bake time and duration and removing tapes allowing them to slowly cool in the dehydrator to prevent condensation. Over the past 3 years, contaminated tapes have become much, much worse. We've had to bake tapes multiple times, increase the heat. On average, we found that instead of making them for 48 hours, we now have to consistently do 72 hours, even with really light, or what appears to be light contamination. And we have also just increased the heat to 130 consistently for both audio and videotape. And we have also been manually cleaning tapes more regularly using a very affordable device called VHS's Life. We do not have the funds to have a big fancy cleaning machine, but this one's been really helpful and working great. And that's just a picture of my coworker Annalise using it to clean a tape. And then this is just a quick example of the documentation that we put together to explain this workflow to the people that we train and to also share with the archival community. Brianna's next, just give me a second. Oh wait, I'm next, sorry, my bad. Bear with me, I have way too many devices up here. All right, I am also going to talk about the impact that this has had on, on open source tools. So there are a lot of tools that are out there, different projects that we all probably use fairly frequently, if not daily. And a lot of these tools are really reliant on, as we all know, a lot of free labor or labor that is supported through government funding, at least in the United States. And we've found that that was another thing that impacted our decision to try to reform the Magnetic Media Crisis Committee, was just knowing that these tools are, sorry, I'm trying to get to my notes. Sorry, I want to make sure we stay with our time, and now I'm taking too long. So yeah, sorry, I won't take up too much time with that. The point really is that as the Magnetic Media Crisis Committee, we're really trying to foster and find new ways that we can support these tools, and either like through finding and crowdsourcing funding or work or testing, just to make sure that they have some longevity within the community. And now it's Brianna's turn.
Okay. So we formed the Magnetic Media Crisis Committee, or the current one, in January 2025. And this group builds off efforts of an EMEA group by a similar name that was active between 2013 and 2016. But that group focused exclusively on video. The new group that we have formed expands our scope to include audio formats. We are also aware that there's data tape on magnetic media, that floppy disks do use magnetic oxide, although it's not on tape. So we believe that our work could be applied to other formats in the future. But this also reflects the broader and deepening crisis. Next slide. So just to tell you a little bit about us and kind of what our goals and mission are, we want to support the archival community working to preserve audio and video magnetic media materials. To do this, we want a structure that provides a collaborative space for knowledge sharing, resource collection, project planning, advocacy, research, and development in order to promote awareness and develop concrete tools and strategies to cope with the growing challenges of degrowlescence. Next slide. Right now we have over 100 members from over 65 organizations across the GLAM sector, and the group is open to all. So there's no experience or skill level requirement to participate. In the spirit of inclusion and the attempt to minimize barriers to entry, we're also not affiliated with any professional organization. And that is because we don't want people to have to pay a membership to participate, because they might not be able to afford it, or if they have limited professional development funds, we don't want them to have to choose where they can spend them, especially if they have a really strong affiliation to some group that we aren't specifically aligned to. All member participation is currently volunteer, and we operate on a pretty small grassroots model since our capacity is limited. We utilize Discord for casual communications and discussion, and we chose this platform because we wanted to facilitate a modular committee structure that allows people to focus on the specific areas of interest that are designated to channels, so that they don't have to necessarily like read an email list that covers every possible topic that the magnetic media crisis involves or touches. So in addition to Discord, we have held optional 1-hour monthly meetings over the past year, but we plan to potentially shift to longer quarterly meetings in the new year. Next slide. In terms of goals, we really want to establish, revise, and maintain best practices. So the baking methods are definitely an example of that. In work that I've done, we do now bake all of our UMatic tapes, and a lot of our workflow has been informed by conversations I've had with Libby and other people. And we want to make this group and the channels for communication as flexible as possible so people can like adapt their work as the media also evolves. To address this work holistically, we include the obsolescence of playback equipment, technical knowledge, and the limited capacity of archivists, because we're humans, as well as the tape itself to be part of our definition of the magnetic media crisis. And as a collective, we want to work modularly, also because we want to consolidate resources, knowledge, time, and labor, which are few and far between, and sometimes there isn't enough for the work that we want to do. An example of this is a group of our members recently submitted a grant together, and another member who runs a D&D group helped us reorganize our Discord to make it more user-friendly. In addition to these more formal goals, we want to shift our mindset to discussing decrelescence. Instead of defining it as sort of an impending doom in a very negative way, we need to come to terms with the possibility that this countdown is kind of ended, decrelescence is here, but action can still be taken. So if we're willing to collaborate, we want to think of this as a human problem with human solutions. And yes, I'm quoting Ben Turkis's thesis because it's still full of good stuff. So we really want to take baby steps and kind of think in more actionable, smaller project-based things that we could do collectively. And I'm going to pass it off to Libby.
So over the past 2 years, Bayvac Media in California has conducted a survey of the current state of magnetic media holdings in the United States and the ability for those responsible for caring for these materials to digitize and preserve them before it's too late. The findings continue to support the urgent need for this work, citing the top challenges as lack of staff, lack of funds, and lack of equipment. None of this is news to us, but it seems like about every 5 years, when surveys like this are conducted, we come back to the same conclusions. The only difference now is we're running out of time, and those resources have gotten even more limited. And one of the main recommendations from this report, I would encourage all of you to read it. It's beautiful, and it's just very informative, and they did a lot of hard work going out and working with different communities. One of the main recommendations that they had, though, was to encourage collaboration and grassroots efforts to combat this escalating doom, which really supports the mission of the Magnetic Media Crisis Committee. And for our activities, we really aim to foster strategic collaboration, promote adaptive workflows, and support the exchange of practical solutions that respond to the rapidly evolving preservation landscape. With an emphasis on collaboration, tech, knowledge, and resources across the profession can be consolidated during this time of uncertainty. Some of the current projects that we have. So to date, members of the Magnetic Media Crisis Committee, man, that's a mouthful, have begun working on a number of projects, including gathering collective expertise on common chemicals used for cleaning, coordinating informal talks on technical areas of interest and DIY solutions, compiling a cookbook of tape baking recipes, providing feedback on a variety of open source tools, facilitating relationships with hobbyists to assist with CRT maintenance, exploring new workflows for better quality VHS transfers using S-video and RF capture, and increasing global membership and representation through community outreach. Throughout the year, we've also had a handful of presentations thanks to Brianna's amazing coordination work. And those have been offered through the Magnetic Media Crisis Committee for free, including one on SVHS QC and QA testing, and my thing does not want to cooperate with me, and DIY mold making. And I think this is you, yeah, Brianna? Okay. Sorry.
So one of the things that we did this year to advocate for the group and just the professional community at large was we wrote an article for CAMA, which is the International Council on Archives. It should be coming out next month. The title of it is Dagger Lessons 10 Years Later, Community Solutions to a Mounting Predicament. And the motivation for this was that we felt like a lot of the advocacy that had been done so far had been within our community, and we're all pretty aware of what the situation is. So we wanted to publish something to an international, more general audience, which is what their publication, CAMA, is for. Within the article, we talk about some of the topics that we've already discussed, such as the evolution of workflows and continued obsolescence of software. And then we also discuss, next slide, the impact of continuing obsolescence of hardware, which we mentioned briefly, but just as equipment ages, it becomes more rare, fragile, and expensive. Next slide. And the continuing obsolescence of knowledge on a sunsetting industry. So we really want to think more creatively about who can we reach out to and collaborate with outside of our direct peers. So are there hobbyist communities that have techniques that would help us? We've discussed hobbyists that work on model trains, and those motors actually work in some video decks. And we also plan to talk to some conservators and time-based media about how they've handled fugitive media or objects deemed at end of life, to see if we could adopt some of those practices that have already been established. Next slide. And then the last thing we mentioned in the article that we felt was more recent was additional factors such as natural disasters that were a result of climate change, such as flooding, that have happened, like not only in the US, but also in Valencia recently. And then of course, the recent termination of the National Endowment for the Humanities and National Endowment for the Arts federal grants, which help develop tools such as DV Rescue and QC tools. Next slide. So obviously we're speaking to all of you because we want this community to be involved. We want the MMCC to be thought of as a sandbox for ideas within the community to assist with proof of concept when we might not have grant money to do really ambitious projects. We can still kind of work towards those things in a smaller way. So next slide. And then on this slide, I just put some things that we've kind of brainstormed that we could use help with, since like sometimes it's hard to think of an access point of how to be involved in a group. So obviously we are really US centric. That's our direct experience. And a lot of our members are from the US. So we'd love to hear from the international community in terms of how your experiences are similar or different. Obviously your funding structures are one of the primary things that are pretty different from ours. We're also we mostly speak English. So if you speak a second language, that's also helpful. And right now the group is pretty heavy on video people. So if you are an expert in audio, we'd really love to have more representation there. One of the things that we wanted to do was start consolidating resources in a central place where it could be updated. So we did create a GitHub, but Libby and I have been doing a lot of the heavy lifting. So it does need work, and we want to get a GitHub pages up so that things could kind of have somewhere to live. And then as they become outdated, people could file issues and hopefully keep them more current. In addition, if you have any research or want to share tape cleaning techniques, that's something we'd like to discuss more. Or if you're an illustrator or an artist, one of our members illustrated all these little tape guys for us. So we want to make our documentation cute and fun. And so if you want to help with design, that's also something that we welcome. Or if you're part of a community outside of AV and you think that there might be things that we should discuss or there might be overlap, we want to hear what you have to say. And last, although we're not affiliated with a professional organization, we do have liaisons in different professional organizations, and that's to try to minimize the duplication of work. So we have people that represent the magnetic media crisis community currently for ANIA, ARSC, and then we recently have someone from FIAF. So if you'd like to be one of those people, let us know. Next slide, and handing it off to you, Libby.
There's our friend right there. While urgent action is needed, we cannot forget that humans are core to our workflows. With large-scale digitization projects, we spin our wheels thinking about budget, equipment, throughput, deadlines, when the invaluable resources that we need tend to be the workers themselves. Don't let the burn down burn you out. That's a quote from Susie Cummings. Make space and time within your workflows to allow humans to be humans. We encounter and experience difficult and traumatic moments through time-based media that can be triggering. Build time into workflows, check in on those who process those materials, and give each other breaks. Offer to be there for each other. Through initiatives like the MMCC, practitioners are continuing to collaborate and innovate despite limited means, developing practical tools. These grassroots community-driven projects demonstrate that progress is not only possible, but inevitable when we work together and share what we know. By drawing on the lessons of the past with renewed focus and urgency, we can adapt and act, preserving what we can while we still can. And yeah, that's it. Yeah, we are really committed to fostering an international community, and we would love to hear your thoughts or questions or how, get you involved in any way we can. So thank you so much.
Thank you so much for that. Any questions? Okay, I see a couple.
Thanks for that. I was just looking to see what your sort of resources are like and wanting to look at things about research on tape baking and things like this. And is the only place where you have these materials? I think it's on GitHub.
No, so the...
Where do you keep that stuff?
MEPOPs or the MMCC?
The MMCC?
Oh, they will go onto GitHub once we get that all set up. We've just, like Brianna said, it's kind of just her and me and a couple other folks helping out when they can. So we just haven't had time to do it. The resources that I showed specifically, those are on MEPOP's website, but they will also be incorporated into the MMC site, along with other resources.
Sure if it was on a different server or what, but it sounds like you'll put it there.
Yes, yeah.
Self-conscious about showing it to this group. And also because we do have quite a few members that aren't as familiar with GitHub or working with HTML. So one of the things we've been doing is we've been having GitHub study sessions where people can become more familiar with GitHub and just the different platforms that we want to use to publish online. So it's just been a really slow process.
I know we have more questions and we have time, but the housekeeping that I was supposed to do when we started, we're scooching. Let's just scooch in as folks came in. If we can just scooch a little bit, you'll have time as, where did my hand go? There we go.
Hi, Libby and Brianna. I was just curious, I'm on the board of YASA, and we did 5 years ago, the Magnetic Tape Alert Project that was in collaboration with UNESCO.
That is definitely included in the comma article.
Okay.
Cited as a resource.
Yeah, but we've been trying to kind of push forward since then without very much success or anything to show for it. But we're an international organization. We have less of an America-centric focus and lots of people that speak multiple languages, and we've done a lot of this work already. So definitely we'd love to talk to you more about this and set up a liaison and collaborate. Yeah, that's all I wanted to say.
Yeah, thank you. Yeah, that'd be great.
One thing that I could say is I think that right now the position we're in is because we don't have money to do a strategic long-term 3-year project. What we're really trying to say within the scope is what's like a small actionable project that you would want to do. I think a lot of us have seen great projects that have been really successful, but they had, you know, a lot of money behind them. And we really want to think about something much smaller. Also because one thing that we're seeing is just a lot of burnout. Like people are dealing with a lot of changes right now in the workforce, along with, you know, just budget cuts in general. And the backlog is just, it's not going away. So I think just sort of adjusting our expectations. And one of that is just like, well, what is fun? Like, I know that sounds really silly, but, you know, like, because Libby and I have had to do a lot of the logistical stuff, and a lot of it has just gone on our shoulders. We're like, okay, well, we're gonna do the things that we enjoy. So the tape baking, the cleaning, that stuff that we're personally invested in. But if people have something else they're interested in, they should definitely lead the charge on that. We're also going to be doing a CRT assessment and maintenance workshop, just because we don't have a lot of techs in the US that can service that equipment, although it's not magnetic media as part of the workflow. And we'll be making a one-sheet guide where people can kind of learn what can you do in-house, like what is the power supply, what do I need to think about, what are some of the failed parts, like if this button always breaks, can I 3D print it, things like that.
Okay, we have a quick question online. All right. It's Dave. It's fine. Because you're next. So let's do the quick question.
You can eat into my presentation that's after yours.
Oh, a comment. Perhaps the upcoming Joint Technical Symposium is a good place to give a presentation like this. Joshua! Hi!
Sorry, what was the question?
It was more of a giving you more work to do type of comment.
Thank you, Joshua. I'll take it under consideration.
We are meeting with the Electronic Media Group, which is part of the American Institute for Conservation, later this month. And one of the things that we're proposing is potentially a Skillshare at their upcoming conference in terms of how they've dealt with fugitive media. And that's just things that aren't really meant to last. I mean, this can be like artwork made out of food, but you know, well, what do people do? That's like an established practice. Like, can't we just apply that to tape too? Like, some of those considerations are the same.
A lot of conversation to be had, maybe over more drinks later. Until then, though, we're going to switch it up with Dave Rice. Hands off to Libby and Brianna. Thank you for joining us. Bye.
Hi, everybody. Lorena was sending me a few emails to upload my slides, but if you don't have any slides, you don't have to upload them or make them. So, and if anyone wants copies of my slides later, and you have like some tracing paper, you can just come up to the podium later. So I don't know. In working on this presentation, I started thinking about, like, I don't know, all the sort of digital media we use and the screen time we're on every day. So sorry, that's why Kieran just shut off our screen for a little bit. You know, maybe there's not enough imagery to look at. You guys can look at me, or you can just gaze at one another if that's too much. Maybe like a lot of you, I sort of knew I wanted to enter this field when I was about 12 years old. I saw this movie on TV. It was like a Marx Brothers movie from 1932, Horse Feathers, and it was like a really bad projection print, and there were lots of splices and edge damage in it, so the gate would kind of move around. And my parents never told me about splices, so I had to figure out all the stuff on my own. And I'd see all of a sudden there'd be like some kind of markings, and then the visuals would jump forward in time, and then in about a second later, the audio would jump forward in time. I mean, from watching, Sesame Street and all of my other favorites of the era, I wasn't really aware of the physicality of the media that I was watching on television. But this movie was like kind of an eye-opening moment for me, because I really became aware of what film is and how it works, because I'd get a little bit of an impression of it, especially like when it's not in the most perfect condition. I didn't know what movie I was seeing, so I just like grabbed a pencil and wrote down all the credits and went to the library, because I didn't have any internet access when I was 12, because there wasn't any. And so eventually I found out what movie that was, and I went to the VHS rental store, and they didn't have it, but they gave me like a bunch of catalogs, and eventually I found like all these. In the back, they had advertisements for these like pirates that would just sell you cheap VHS tape dubs of movies, and then I noticed some look good and some look really, really terrible, and then a lot you just can't get at all because they're lost or nobody made a copy. So gradually I figured out that there's some archivists out there, and if they have a role, so started moving in that direction professionally. So in 2003, I started going to school at the L. Jeffrey Selznick School of Film Preservation at the George Eastman House. I think it's the museum now. It was the house when I was there. But this was like, one of the most terrific educational experiences of my life, just sort of delving into something that I had this developing passion for. And it really taught film preservation as a craft of, just building upon decades of work of the technicians and archivists there in like how to preserve cinema. And then around that same time, all these folks working on digital technologies, were starting to move into archival spaces as film preservation. And I don't know, at the time, the perspective was just like, who are these noobs coming along with this digital whatever? And like, why are they here in a field that really has been a craft that's been developed over decades? Eventually we'd start learning more and more about digital. Like we'd hear about these bit flips, and I feel like I've worked with millions and millions of files and probably like 4 petabytes of data at this point, and I think they've been quite rare. I've seen a ton of corruption, sector loss, broken hard drives, broken storage devices, but I remember like the bit flips were like, we'd just be so scared all the time. But so I remember we'd start like learning a little bit about digital, but from the context of a very analog environment where we were focused on analog preservation practices. And I remember like an instructor just telling us that like when film would decay over time, which was kind of inevitable, it could be slowed through conservation practices, but that the decay of physical film kind of had a grace and a class to it, where you could see over time by taking recordings and notes that the shrunkedness of a film would increase over time, and the brittleness, and it would eventually need like more splices that. It'd be like if you leave your food out overnight and you come back like after vacation and you see it looks different. Like, you'd be able to see the progress of decay over time. And the instructor made this analogy that with digital, it's completely unobservable, that the bit flips are just always happening and we don't even know where they are or what. But then at some point, the data has corrupted so much that the file will be completely unplayable and completely unfixable. Of course, later I found out that wasn't true at all, that there really is an analogy to doing restoration of data that's been damaged to make repairs. I don't know, I spent a lot of my personal career like in that very subject of trying to like build out that like analogy between working to like repair and restore data as with the same sort of craft level that I was learning to do so with film. You know, but it was an era where there was a lot of mystery about digital. I'm talking about like, you know, 2003 era. I remember reading this website forum. Somebody was completely convinced that every time you look at a JPEG, it gets a little bit worse. So like, you know, if you open it up and then you close it and then you came back later, like you might be able to, it'll be subtle, but it'll be a little worse. And eventually I realized that they're talking about like, oh, when you open a compressed image in like Photoshop and you edit it and you resave it with a new round of compression, that there'll be some generational loss built up over time. But I don't know, for a group who was just totally new to like how digital storage impacts media, you know, I think some people really got confused and like truly believed things like this. I don't know, so later at work, I remember having this conversation with a colleague, Brian Camp. He was a curator, and he was like really miming out that like typical action of like holding 35 millimeter up to light, and he was imagining if you were like, you know, coming after, you know, in this apocalyptic era, and you were finding a film archive after like our humankind has been destroyed, that, you know, you could look at a piece of cinema and, you know, start to understand or see that these images are temporally linked in time, and there's sprockets that could give you a mechanical way to like move them through a machine, and there's a visualization of audio. And he was just like, there's nothing like nobody would see data and think something coherent like that of like how to imagine it. But I think later that year I was at a FOSDEM conference, Free Open Source Developers European meeting, and Derek Boitnos gave like a really wonderful presentation on reverse engineering proprietary video codecs to build new decoders in FFmpeg. And it was the exact same thing my colleague was talking about with 35 millimeter. You know, he'd just be like, look at these bytes. I can completely see like, oh, here's the frame headers, here's the patterns that demark different images and transitions between sound. So, you know, I was like, you know, these two people, they would never be able to have a coherent conversation. They just like completely wouldn't understand each other. But I don't know, I felt like they were just, you know, making the same points and really drawing that there's sort of an analogy between analog preservation practices and digital preservation practices. But like obviously like moving digital innovation opportunities into the land of film preservation was quite a bit slower than it was for audio tape preservation and videotape preservation. So in some ways I feel like the communities like for videotape, they benefited from, I don't know if you just remember like the long exhaustive debates of people trying to get the last word about like uncompressed and JPEG 2000 and MXF and FFV1. You know, we would just go to conferences and we'd all have our favorite codec that does exactly the same thing, and we just like argue all the time about this. And I don't know, I think that really sort of refined like our expectations for how we store things, how self-descriptive they are, how resilient, and just the role of standards in our communities. And I don't know, I feel like because you know, film just requires such a massive like scaled up approach when it's integrating anything digital, that conversation was quite a bit delayed. That, you know, it took longer for the sort of skepticism between communities coming from an analog perspective and a digital perspective to actually find that same harmony. You know, we're starting to see it more and more where there's more discussion about like, is it just DPX all day, all night, or, you know, the role of FFV1 or rock hooked in a community like this, what are our expectations for like, what do we want from a film scanner if we're gonna store that information long term? Yeah, so when I was, I don't know, so I was starting to think about how our community like really emphasizes a lot of the innovation that we have in digital realms. Like so many of the presentations are like in this category too, but I just was wondering like if we need to do more in the analog side of our innovation work and just put more attention there as well. I was discussing this a bit with one friend, like, I don't know, just asking her experiences with digital versus analog media. And I don't know, she was kind of making the case that a lot of her experience of analog media at the moment was just for like nostalgic purposes, just like, I don't know, remembering the vinyl that her parents gave her, or, you know, a mixtape that she got when she was a teenager. You know, that there was a lot of nostalgia for these objects. And, you know, as if that was like all of their worth at this moment. But I had another friend come to New York City from Switzerland, and I was asking her impression of New Yorkers. I was just curious, like, what she fucking thought of us. And she said that like one of the things she really noticed is that New Yorkers read books on the subway. And I was thinking about how like when I'd ride the subway like 10, 15 years ago, you'd just see like all these expensive Kindles and iPads, and now it's 80% of them are probably just staring at their phone. But then like there's now just like people have library books and physical books. I don't know if you agree with me, Ben, but I don't know. I feel like there's sort of like a return from, we all, I don't know if everyone, but like there was a huge sale of Kindles and iPads for emulating the digital version of the book experience. But I don't know if it really held favor, and eventually people went sort of more back into the analog direction. I mean, partly because I think we all just experienced so much digital burnout from just like staring at screens and having these like very specific LCD screens like just feed us so much information. And another way this really came up for me so strongly is I was I had this consultancy where I was making a digitization station for a small like video art company. So I was adding in the U-matic decks and the VHS decks and the time-based correctors and like just trying to get everything quite perfect with the computers and everything. So I don't know, I was just making sure like all the data is going through the time-based corrector. I had exactly 10-bit, not getting like truncated down to 8-bit and then padded back up, that everything's like truly lossless. Just trying to have everything as refined as I could. But the end result was being displayed on like an HD broadcast monitor. And I remember the artist came in and like for the first time he was seeing his work from the 80s being presented back, and he just got really upset. And he's like, "This looks terrible. This looks nothing like what he had only seen it in the context of being projected on an analog CRT, and everyone who had seen this work up until I invited him in to see how great this digitization setup had only seen this on a CRT as well." So I don't know. I really realized that even though I had put so much meticulous attention into the digital side of this work, I really just fucked up the whole of it because it just completely neglected the experience of what this artist had intended this to look like. I mean, you can see this more and more, like if you look into the retro gaming community, like there's just so much effort on grabbing these CRTs and replicating the original playback the way the way Pac-Man was intended to be seen, rather than trying to give you this kind of digital counterpart that honestly looks quite different. I don't know, so this was a real learning experience for me, and I started to experience give more and more appreciation to spaces that maintained analog access to objects that originated in analog forms. Like when you see CRTs or film projectors in like a museum environment. I know in New York, the screen slate listing that lists movies will let you know what format it is, if it's a DCP or 35 or 16, and like that option does do a lot for compelling me to see if I want to see it or not. I don't know, I went to see a movie a friend recommended from the 80s, and it was just the most well-worn projection print. I was just thinking of how many people sat in similar rooms having a very similar experience with this very object. So I don't know, like I do sort of like want to hear some experiences from the room if we need more efforts on the analog sides of our work. Because I've been sort of gradually trying to open my eyes to it more and more. Early this year, I was at the Nitrate Picture Show in Rochester, where they show projection prints from, I don't know, the Nitrate era, from the 1910s through the 1950s, I think. But we got to see like a 1941 projection print of The Wizard of Oz, and it's just like in the exact color that people saw it in back in the day, rather than, the sort of like oversaturated, adjusted version that a lot of the modern restorations and presentations have. I don't know. So even though there can be really a lot of efforts, to look over a vast collection of analog objects and just push that we need to scan everything, we need to digitize everything. I just want to make sure that in our spaces we're maintaining a way to experience that object that is authentic. So, even if some people are watching it on their phone or on the back of an airplane seat, that we still have an opportunity to see it on a CRT or see it projected through a projector. Oh, but one thing I wanted to mention about the Nitrate Picture Show is when they began, they would project films that I think were up to 1% shrunken, and then I think they expanded it to a little over 2% shrunken. And that was kind of coming about from like expanding their skills and practice with working with shrunken film and developing out that expertise more and more. But by doing so, they really like opened up a huge catalog of like what nitrate prints could qualify to be projected to a current audience. And through like some related advocacy in film preservation and film accessibility, they were, the director there was saying that there's at least 2 nations now that are working to like legalize nitrate projection again, because in a lot of nations this was, made illegal decades ago. And then I also just like wanted to give a shout out to the Pordenone Festival, which just happened this prior week, which is another place where seeing film in its most authentic like form is quite well practiced. Yeah, so I don't know. I want to conclude by, in another community, I think I was thinking about kind of on a parallel to the retro gaming community being an inspiration for us was just like the DJ community. Like there's a lot of emphasis on bringing vinyl to venues. And I noticed that like one preferred record player for DJs, like at least in New York, is the Technics SL 1200, which is a decades old, lovely record player. And I found this website that just goes into like, all the original user manuals, but then all the information about how to replace belts, fix parts, get replacements. I just like wanted to see the same love for like the U-matic decks and like the VHS decks that like, we have where, we can come together to like organize information and expertise so that we can really hold on to an ability to offer analog experiences to objects that originated in analog form. All right, so that's my talk. I'd love to hear some comments, like if you have any experiences of holding on to analog exhibition or doing any innovation in analog spaces.
Great presentation. I really enjoyed that. And I hope in a way you're making a call that I've been making for a long time to please do not throw the originals. I did a presentation years ago about how reformatting is essentially a form of translation. So just because you can translate Anna Karenina into English and there's more people who may have access to that, probably reading in the original Russian is better. So the fact that you have more access and you have more copies doesn't mean you should throw away the original, which is something that I hear more and more, like in broadcasting stations, they're throwing away the original tape. So hopefully all of us are in agreement. And as far as having the analog machines available, I've always thought that a model similar to telescopes would be perhaps useful to our community, where you don't have to maintain the telescope yourself. You can hire time in a facility that is maintained by someone with expertise. And so I want to throw that out there. Thank you.
Thank you.
I have a question. The colleague of yours who suggested that it's probably possible to understand what to do with the 35 millimeter prints. Did he also suggest how you would be able to hear the audio?
I mean, he was getting into that a bit in his miming. He wasn't trying to play out the entire process of replicating all the optics and machinery and the multi-skate but yeah, he was trying to say he was betting if you had 2 rooms of equally intelligent and diverse expertises in 2 rooms, and you gave one 35 millimeter print and the other some obscure audiovisual data stream, that the analog team would solve the problem of recreating the exhibition experience first. But I don't terribly believe that. I think the effort to make a 35 millimeter projector out of nothing is substantial, but.
Thank you, Dave, for the talk. I wanted to mention, because you mentioned ScreenSlate in New York for rep film listings, and they'll talk about if the print is on 35 millimeter or DCP or whatever. I live in LA, and I think there's at least 7 or 8 now rep theaters in LA versus like only 3 or 4 even pre-pandemic, where you can see a film projection. And every single one of those has a tradition of thanking the projectionist by name before the screening. So
Are you
like
saying there's more analog exhibition post-pandemic than pre-pandemic?
In LA, yes. I think it's actually doubled from about 4 theaters to about 8 across town.
Do you have any idea why?
Because people are moving there and they are all 37 and don't care about anything else. That's speaking for myself. But I think it has certainly helped. Like there's a local scene around it, right? And I think this is a completely different angle, but because I was talking about shader programming, we're seeing a lot more like really good, authentic digital efforts at reconstructing analog viewing techniques than we had even a few years ago. Like I think until 5 or 10 years ago, I was trying to get at this with a research paper, trying to drive at like the same glitch affect lexicon as I forgot the name offhand. She's a well-known. I'll get to it. Sorry? No, but yeah, it's okay. Anyway, our ability to reconstruct analog viewing in a way that is no longer just kind of like kitsch and like a poor effort through new shader programming has gotten much, much better. So you'll see, for example, the AV1 spec, lets people add grain on the end of the decoder rather than having to encode the grain. And like those are deliberate choices being made, I think, by standards bodies that are really improving the way we present digital media in a way that's respectful of analog media.
Oh, I thought you were going to keep talking, so I was like, I'll just set up the next.
I'm taking over
Sorry,
question.
I was giving that impression. There we go. Pass it down.
Yeah. David Zucker's got one.
Just an experience with regard to equipment. I also install 16mm projections in exhibitions with loop projectors or loopers on portable projectors, and the producers of these projectors, like Eiki or Bauer, would go on into the 90s to produce machines, and these machines become older and older and harder to maintain. Also, they would go on adding features to these projectors. And for the projection as a loop in an exhibition, you need a very basic machine. So a few years ago, my idea was, okay, maybe we should produce a new projector head just aimed at loop projections, because for the 16mm format, that's probably the most actual use case for films still being projected nowadays. So I went to the two main heads in Europe to discuss with them, does it make sense to try to set up to try to produce a new 16mm projector aimed at this use case? And both of them said, there's so many old projectors and we know how to maintain them. And since then, one has died and the other moved to Japan, and is not, his knowledge is not accessible anymore. So that, I think that's kind of typical, that there's a few people who know how to do things, but they die out in one way or another. And so, yeah, we should, particularly for the equipment, if we want to keep showing analog materials, we should have an eye at the equipment, not only in the area of video, but also in the area of film.
Okay, sure. Like one question about the Pordenone. Right now, I think more than half of the film in Pordenone are also digital. So I don't know if it's sad news or good, but I think at some point our goal to reach the original experience analog with silent movie, because it's a silent movie festival, is you cannot reach it because digital give you so much more option of restoration, bringing film also as a text together. That's also important. Yeah, and also in line what you just said, that is not so much only a problem of carrier itself, but the whole apparatus in case of film. That it's not only the people who run the film projectors, but there is, when you already have a digital projector, you cannot squeeze two analog projectors. So it's all so complicated that my colleagues usually have a problem with with maintenance not of the equipment and less with buying the film stock or on printing it. So it's the carriers are sometimes the least of the problem, but the whole apparatus and understanding it is an issue. Yeah.
Okay, thank you so much. Round of applause. And now a very timely talk about preserving under pressure, navigating federal funding loss as a community response to magnetic media decline. Libby.
Hello, everyone. It's me again. My name is Libby Hopfoff. I realize I didn't introduce myself at all for my last presentation, so just to tell you a little bit about who I am so you understand where I'm coming from, especially in the context of what I'm about to talk about. I am from Seattle, Washington. I work for two different organizations. One is the Seattle Municipal Archives, where I am their audiovisual archivist, and I also work for Movie and Image Preservation of Puget Sound. I love being parts of groups with really long names, where we go by MePops, and we're a small nonprofit. We work with other nonprofits, mostly locally, but pretty much anywhere, anyone who wants to work with us to help them digitize their materials. These are usually organizations that are collecting magnetic media, like audio and videotape. We don't work with film yet, but we train them through the whole workflow and get them all set up so that they can care for their materials and really understand the entire process, not just provide vendor-type services for them. We also help them with storage solutions and long-term backups. We provide needs-based long-term digital preservation on LTO tape for organizations who can't afford it, which we found out really quickly were most of the organizations in the area. But yeah, we're a small little group. But one of the main things that we, really has been a core part of our mission since the beginning, we've been around for about 10 years, is letting people know about the magnetic media crisis. And now, so this actually kind of fits in really well with the last presentation and the presentation before that. So I promise some of these images will look a little similar, but they are not, I'm not gonna repeat what I say, I promise. So before we begin, I just want to acknowledge that this issue doesn't affect all archives and archivists equally. The loss of federal funding is at the moment really a challenge that's kind of a United States problem. However, just over the last 2 days, I've learned from multiple people that I've talked with that budget cuts are sort of becoming common across the heritage sector across the world, which is really disheartening. But also that said, many of the tools and projects that we use for daily work are typically at least partially paid for by the federal government in the United States. And a lot of those granting opportunities have disappeared. There is no longer research and development program at the National Endowment for the Humanities, which has funded a lot of work for QC Tools, DV Rescue, I don't think VRecord, but just a lot of different tools at different times. And those investments have strengthened those tools because it's a huge chunk of money that usually allows for more capacity, more manpower, the ability for people to travel to conferences like this and participate in the community, and just all sorts of things that in the long run benefit the entire global archival community. And so my hope for this session is that we can have more, instead of me talking at you, we can have more of a constructive conversation about how we as the archival community can respond to this loss. How can we continue supporting critical audiovisual preservation work together, not just the actual digitizing, but also these open source tools that we all rely on, and in the absence of this funding. And ideally, what I'm hoping, like maybe I'm being naive, is that we'll come away from this conversation with at least maybe a couple actionable ideas that we can implement right away so that we can continue to support each other, because I don't know about you, but I'm so tired. And we need to do this before no money is there at all and we don't have anything left. And the tapes day, there's that too. Speaking of, from the same report that I was talking about earlier from Bayvac Media. Full disclosure, I was part of the advisory committee, but I didn't do any of the work. It's just really amazing, and the entire purpose of it was to be an advocacy tool, so I'm doing that. I'm using it, as an advocacy tool. And I just want to point out here that this is one of the quotes from the report, that approximately 80% of the survey respondents, of which there were 153, I believe, were funded in part by government grants, and 87 report receiving non-government grants for their organizations. And one interviewee shared pretty much any digitizing project we do is grant funded. And then it happened to appear right above this really depressing bar graph where a vast majority of these organizations are now really concerned that they won't ever be able to digitize their materials before they die. Through that survey took over 2 years for Bayvac to put together, and it inspired a local granting organization in Washington to pay MEPOPs to specifically go out and talk to people in the Pacific Northwest and ask them similar questions so that they could reformat their non-federally funded grant program to help preserve collections. And I know you'll be shocked to find out that our findings very closely mirrored that of Bayvac's. A lot of people cited the same problems, lack of funds being the number one, lack of equipment, staff capacity, just all these same problems, which really all boil down to funds, essentially, because you need to pay people and you need to buy equipment or buy server space or all these things cost money, and people should be paid for their time. Like I said, I'm really hoping we can have like a conversation about this, and just so people don't feel like they're the first one to say something, I will be vulnerable and I will share a story. So as I kind of mentioned briefly in my presentation with Brianna, the loss of these funding streams hasn't just affected institutions and at-risk collections, it's also really had a huge impact on open source tools. And an example that I've had experience with was MEPOPs worked with Dave Rice and Jerome and Andrew Weaver and Ashley Bluer on the DB Rescue project, which is I know everyone's heard my DB Rescue pitch many times, so I won't dive into that, but we received 2 research and development grants over the course of 5 years, which unfortunately coincided with COVID, and that impacted some of the work. But over the course of 5 years, we developed DV Rescue, which is a set of tools to digitize or to transfer content from DV videotape formats. But it was, while there's a lot of in-kind support, some from people in this room who were our project partners and did testing and gave us feedback, all of that work was completely paid for by the National Endowment for the Humanities. And now that it is shuttered, we don't even have the opportunity to apply for another grant for that. So the outlook for funding for that is bleak. And not to brag, but DV Rescue is a pretty big deal, and it was a major advancement that was really supported by this funding, and we were really excited about it. It was really helpful to be able to actually help people get these materials off of these tapes because all of the other tools were no longer available. But DV Rescue isn't unique in that way. Like I said before, a lot of different projects have been funded at least partially by, if not direct federal grants. They've been funded by federal organizations like the Smithsonian or the Library of Congress. And with our government shutdown, it's just really unclear what the future of that will, how that will take place. So yeah, I would now like to open the floor to a community discussion. I have a few questions to prompt us for brainstorming ideas, and we have a lot of time. So if people want to limit their questions to, 2 minutes, if we have extra time, then we can circle back to people who would like to say more. And one of the main recommendations, like I said previously, from the Mapping the Magnetic Media Landscape report was to encourage collaboration and grassroots efforts to combat this escalating doom. And so this is again, maybe my naive attempt to try to jumpstart that for this community. But yeah, here's my first set of questions. How has the reduction or loss of federal funding already affected your organization's preservation work or planning? Which specific programs or types of support, like grants, training, partnerships, have been the most critical to your audiovisual preservation efforts? Should I read all of them? And then I'll read all of them, then you guys can decide what you want to talk about. So then relating to community and collaboration, what models of collaboration, regional, institutional, or grassroots might help offset reduced funding and shared capacity gaps? How can archivists strengthen networks to pool expertise or resources for magnetic media preservation? Are there examples of successful cooperative preservation initiatives that could be scaled or adapted to new funding realities? In the absence of federal funding, what alternative funding models, community fundraising, institutional partnerships, local government support, et cetera, might be viable? Can we balance the urgency of at-risk media preservation with the need to build sustainable and long-term infrastructure? And then moving forward, what immediate concrete steps can this community take to support one another and maintain momentum despite funding instability? And what does collective resilience look like for our field at this moment, and how can we ensure no institution or region is left behind?
Thank you, Libby, for giving us this space. So I see a hand up.
Hi, thanks. I'm Eddie Colleton. I'm a freelancer, but I teach workshops for two nonprofits. One's called Voices in Contemporary Art, which is a confusing acronym, VOCA. It's the O in voices instead of the I. Anyway, and the other one's called Myriad, and they both had NEH grants to teach these workshops for preservation for small and mid-sized art museums doing time-based media or collecting time-based media and video art, things like that. The VOCA workshop was scheduled for November, and it was going to be in San Juan, Puerto Rico, and it was canceled when the NEH grants were canceled, which was really sad. I had bought like a Cangrejeros Roberto Clemente hat and all this stuff. I was very excited. That workshop is getting replaced by one, again, assuming the government ever reopens, that is going to be replaced by one in New York at the National Museum of the American Indian, which is not a replacement, but VOCA has a wide network. They're very involved in lots of museums, and the news that our workshop was canceled sort of traveled throughout all of those museums. And because the Smithsonian is better resourced than most art museums, they were able to sort of pick up the slack and essentially replace this workshop with another one. So not entirely like a replicable solution, of course, but this community building, which is of course a theme of the conference in general, and this like distribution of information throughout networks, particularly to museums that do have, or I should say institutions that do have the resources to step up and try to fill gaps is one approach. One of my other clients is an art gallery, and they work with what is the Nike? They're in Portland, the Knight Foundation, who has like jumped in and taken over a lot of NEH grants as well, which is sort of like just contributing to our like sort of medieval like fiefdom economy situation, unfortunately, but is better than these programs disappearing entirely, I guess. So that's yeah.
So at least within the US, fun fact, in New York, there are a lot of places that you just need to sign up and you get free space, which is a very big deal sometimes. They're like where we need to find space. So maybe we just do a little, oh, we're Pier 57, free space, you can use it. If you find yourselves in a US state and you're like, we have something similar, let's put that together. Okay, done.
Thanks, Libby, for putting this together. I think it's a really important topic for us to all talk about. So I work in a slightly different sector, more in the nonprofit, NGO, human rights kind of world, and I can say like all of this loss of funding, the funding cuts and budget cuts that you're talking about here is like, affecting us in the exact same way. And we don't work primarily in the United States, we work globally. So, it's affecting us, our partners, global partners everywhere. And I don't have anything like a good suggestion, but my fear is it's not just about like loss of project funds and the inability to do projects and work, but it's more sort of existential. Like for us and a lot of the groups that we work with, my fear is not just that we can't do the work, but these organizations will cease to exist. People will leave the sector. They have to find jobs somewhere else. And so, at some point when the funding does come back, if it does come back, like it's not going to be that easy to just restart again. Like the people are gone, the institutions, the organizations are gone, and I don't know what a suggestion to deal with that is.
No, I think that's really, thank you. I think that's really, really important. And I think, at least for me, like I am so freaked out about what's happening right now that like even thinking about the future is a little scary, but we have to, right? Because that would be a huge loss. It's like if we lost someone like Witness or another organization that's providing vital things. Oh, sorry. I was like, what?
And not
So
to
thank you.
not to speak for Libby, but it doesn't have to answer, like your comments or questions don't have to answer a question. It can just be like, I'm worried too.
Yeah, this
like the space.
Yes. Yeah, sure. Sorry, I tried to put them all on one slide and then I didn't. Maybe if I end the slide, there's got to be a way to do that, right?
Yeah, I'll go in regular mode. Why'd you make it?
But thank you for saying that. We're not this isn't supposed to be about me. I just wanted to, even if you want to just have a second to complain, this is also the space for that as well.
See the man behind the curtain right
Yeah.
now.
We'll get those questions up though.
That's as close as we're gonna get it. So I think we understand the landscape. We're gonna keep these up.
So this is more of a comment.
That's perfect.
From my experience, I feel like when we're preservationists and conservators and the people we work with in our institutions mostly don't know how to handle stuff or how to treat it properly. And I think it would be a good start to educate the people around us more. So there would be more of a conscious effort to actually secure funding or even just try to improve the existing conditions we have. Because most of the time, I am a conservator, so most of the time when I work with like art historians or curators, they know about the historical aspect of it or the impact it has, but they don't really know how to care for it. And a lot of the time I have to argue for the artworks or a lot of the things, and they don't really understand it sometimes, and I know it's important to have both perspectives, but I also feel like there is definitely a big gap between understanding each other. And I think if we try to bridge that gap, it would improve a lot, even from the inside. Yeah.
I couldn't agree more. And I know I don't work in a museum, but I know that like improving the relationship that I had with the IT department at my one position made a huge, huge difference. So all that to say, I completely agree.
I agree, and I think like in terms of practical steps, New Zealand are going through this now, but when I started back in 2012, I'm not there any longer. Like there were a few of us turned up from different countries who landed in an organization that was just about to have a government reshuffle and all of the funding taken away. And yeah, this actually resonates. I wasn't sure if it would, although I agree entirely. What practical steps that we did was we cut our losses on some of the projects that we really wanted to do, but we're too ambitious. So if you think about it, like we had a great team. It was like a really good prototype for how you conduct, these projects. Like it was about, 6 people with 2 people in different disciplines each. And the projects we had were like 500,000 digital objects. And we had to just cut them all and just start, we had to just say, this isn't feasible, right? We only have each other. We had each other in the team. We had each other in the organization. So we went back from 500,000 objects to like 200 objects. And then it became 1,000 objects, 4,000 objects, 10,000 objects. And then we used that actually to then use that to communicate across the rest of the organization about the importance of, doing that work and building digital capacity within the organization. And they started, and everyone, we used it for training, we used it for workshopping, we used it for building capacity. And I think what I've seen since I've left is that the funding improved for them for a little bit, and that team more and more able to take on more ambitious projects. So you can use that time to prep now, so that in 3.5 years, fingers crossed time, everything, you're ready to hit the road running again and just go.
Sure, yeah. I don't know if that'll be a reality for me personally, but I definitely think that sounds like a scalable way to, how did you prioritize which projects or which things to, how did you prioritize?
Well, interestingly, because I think those big things that we had, they just felt really immediate because they'd been very recent, and digital is new, and these things were from the past 5 years. So we just actually looked further back into the archives and said, what other backlog have we have that's older, that's still going to be informative? So in that case, maybe we were lucky, right? Maybe I'm sure not everyone is in this position. It's because maybe your material is that specific. You need the specialist equipment all the time, and you need this all the stuff you touched on and Dave touched on. But we had collections that were backlog, and we were just well, now's the time to go into the backlog and deal with that.
That's great, thank you.
Yeah, I think I take a lot of lessons from the DIY and a lot of the scenes and the artists for whom we're stewards of their work, right? I think there's a real magic in how people created despite constraint, and really relied on sort of popularization of methodologies and knowledge to be able to do filmmaking work, to do creative work, right? Doing it on the cheap and doing it in a way that felt empowered and autonomous became a mode of filmmaking that was so critical, because the only mode that seemed possible was industrial filmmaking, right, in Hollywood. So I think there's a lot to be learned from that. And for me, I think the thing that I take a lot is the idea of popularization of archiving. The word archive and the ideas and the concepts and the theories around it have never been more popular. And I hear it all the time in popular discourse of people so excited about preservation and so interested and so engaged with this work. But I think there's a gap in the professionalization of archiving where we sort of can get insular, where we look inside our institutions and look inside our bureaucracies and can forget that there's this whole world who cares very deeply about our work and who wants to be engaged. And I think popularization of education, popularization of our work is really key to a more sustainable mode of preservation, right? That like we need to be working in tandem with people in a more DIY and alternative way to be able to be deeper engaged with the work that we're doing and do it in a long-term sustainable way, rather than just looking to like these failing institutions that are hostile to the very people who care, right? Like it's an interesting landscape, and I think there's so much to be learned from the people doing it in a sort of anarchist DIY approach of education and popularization. I think is really important.
I couldn't agree more. Is there anyone?
I got one. That's okay. This is going to sound cynical, but I promise it's not. I think we should get a little better, if we can, at trying to get private capital, private philanthropic capital to do some stuff like this. And hear me out here, because I think it's a bad model. We'd all rather have state funding. The world is becoming more unequal. There's more privately concentrated wealth. In some cases, you see that with museums that are not relying on government funding, having better endowments, and that's all great for the museum goers, right? There's pros and cons. Structurally bad, sometimes situationally good. I think in the case of DV Rescue, for example, right? Here's a really good example. DV Rescue, DV Cam, popular format, late 90s, early 2000s. You know, for us, because we like DIY communities, because we like documentary filmmakers, the 2002 Steve Coogan classic, 24-Hour Party People. There's lots of reasons to like DV Cam, right? But I'm sure you can find some founding engineer who had a $30 million startup exit who really likes skate videos, right? You're like something like that. That's your funding source, right? Approach it on that basis. Be like, hey, we're going to get this resource to help bring the whole community of DV Cam users up forward because you, guy who happens to be rich for probably bad reasons, you like skate videos. Right? And I think if we could do that and we can operationalize that a little bit better and we could think about, you know, here's the candy, here's the cake, we're all going to get to eat it too. Like, there's something there, potentially.
That is an excellent question.
So, how many people use open source tools? How many people say they use open source tools on some sort of platform? Like if you have a website, you have the logos up. If you do presentations, you put the logos up. How many of you let those developers know you are using their tools? There's way less hands now. So I'm saying this because I work at an open source tool company, so disclaimer, sorry. And a lot of the times, we want to get more feedback from people, and we get it as, your tool isn't working. It's like, awesome, didn't know you were using it. So if you let us know, that's great. So we're actually trying, so I work at a company called Web Recorder, we do web archiving. And so there's a whole enterprise field that we want to charge what their budget can charge, so we can make it more accessible to all of us. But it looks really bad when we don't have people like, you know, this institution's using the tool, this institution's, like, we just need a logo. Like, that would be nice. And to know that you're using it, that way we can hype it up, and then we can go to these enterprise companies saying, so $1 million is like a cent for you. Can we get this? And it'd be like, cool, because look at all the resources you have. Look at all these people in your community that use it, and it's vetted. So thank you for using open source tools.
I'll make you a logo.
Let your developers know that, one, it's appreciated, and that you're using it, and that you give them permission to use your logo or like information to put it on the site. So thanks.
No, that's a really good point. Like, I honestly
just to make a short.
Oh, sorry, yeah, just let her finish.
I just anecdotic. Yes. What I think that's how we got the second NEH grant, was by being able to prove how many users we had, because that says a lot, right? And yeah, just to say I agree and yes.
Two small comments. First of all, I see a FireWire on the device that is not FireWire only. So it's about the presentation. And second will be the comment. We not good to use FireWire because only DV and Mini DV have 420 encoding. All the rest they have 422, and you lost some color resolution if you used 420. And about the problem with discussing, I will answer with very popular in my country joke. You will understand, I hope, really what we talk about. The joke is that some gentleman saw on the street 2 dwarf, and he asked them, "Who are you?" They answer, "We are 7 dwarf." And he asked, "How are you 7 dwarf if you're only 2?" They say, "No manpower, guy, no manpower." And I hope you understand the joke. There is no people qualified, and yeah, this joke work very well in our region. Maybe here not very well, but I hope this is the essence of the problem. There is no prepared people, and I hope that after every no time to wait, at least 2-3 people will be catch it in our part in order to use them for this one, because as you know, the archivist is half engineer and half artistic. And those is very rare species because people are all engineers and mathematicians or artists. And to be 50-50, it's already some gift and very rare species. Thank you.
I'm sorry, were you referring to this right here? Yes. Yeah, so the way that DV Rescue works is it operates over FireWire so that we can get the audio, the video, and the data stream to give us all of that like provenance information and a lot of other things. Dave could, but is that, you're saying that that's not correct? Or?
Yes, but you need to use only for DV and Mini DV. If you digitize digital Betacam or Betacam or whatever else, there are 422.
The scope of the project was just DV, Mini DV, DVC Pro, DVC Pro 50, HDV, and every other digital
DVC
video
Pro
tape.
as well is 422.
Sorry, what?
DVC Pro and other outside DV and Mini DV are 422.
Yep. Yeah.
See, so this is where highlighting the logos in areas so we can all be like reading up on the documentation is very useful. Also, as archivists, as we're talking about funding, we do the best that we can with what we got, with the time and like bandwidth. So documentation is always nice to be like, I wish I could have done this, but I couldn't because XYZ. And then hopefully someone in the future would be like, oh, haha, I know how to fix that now.
Really quick to your point about letting people know, because I'm going to take a shortcut because I haven't Googled it, and maybe someone online will know. Maybe it was Ed Summers. But I believe there's like it's a bit passive maybe, I'm not sure, but if you have like a page of your own, I think you like there's a standard for having, is it called a slash page, where you like slash something and you list like maybe using an open graph or something, the technologies and projects you use yourself in your own projects. And I don't know, I mean, once upon a time that used to be able to be crawled by web crawlers and optimized by search engines, but maybe it is a good way of like, you know, showing your flair or something, right?
That would be nice. It's a little bit too technical for some folks. Okay, yeah. But maybe a workshop.
Hi, thank you for your talk. I know a lot of us Americans are thinking of the US right now and its crisis, but I think that this is always an ongoing issue and globally. And I'm always really heartened when I see new people coming into the field. And I think in the current moment of crisis, I've seen a lot of people who have just come out of their education getting really discouraged and not knowing all the resources that we know. And so I just want to plug talking to the new graduates that you know and the people who are coming into the field and just telling them that this community is so rich and so supportive, and not just No Time to Wait, but broadly. And when you see a job that doesn't apply to you because it's not your stage of career, email it to that person that you just talked to over coffee. Take that time, because it really does change the community and change the field. And so I'm just, as much as, we're all in different institutions that are differently resourced, like we have our own experience that is individual, and just like supporting those folks and bringing them in constantly, I think will help the field sustain itself in the future.
Couldn't agree more. Everybody, please do that.
Okay, just because we're ending the presentation doesn't mean the space or the conversation still isn't there. Okay, we'll have time for one more. Dave said it was okay.
I'm just aware. Maybe everyone's already aware of these efforts, but some other similar situations that came to mind in the past. The Suko response, the Suko response to the Ukraine situation, where they started mass capturing online resources, but then it moved into digitization as well. They were standing out digitization stations. There's the Data Rescue and the SciOp.net initiatives, which have come out of the collapse of online resources from the US. Maybe they're communities we could reach out to and model from. They're exploring kind of volunteer networks, distributing data between themselves and that kind of thing. But I would also like to say, to me, there's two strands to this. There's the doing more with less, which is important, but I did the analysis on the British Library where I used to work figures, and over since 2007, they got a real terms cut of a third in funding, so 66%, and a massive, and we'll also preserve the entire UK web and digital output of the nation, right? So it's harsh. And I'm a bit tired of only doing more with less, so I also want to learn how to fight, right? So if anyone's got advice on what messages need to be in what rooms, then I'm all up for hearing about it, all right? So thank you.
And then I see another hand. So you can hit the mic and then.
Which one first?
It was just a really short add-on to what Andy just said, and we're talking a lot about grant funding and which is short-term funding, but how do we get our work part of, I guess, what I would call it Cambridge, or what we call it Cambridge, is like core business, and it's like ongoing committed funding rather than funding that we have to search elsewhere for.
Grant, you're supposed to say something about like, what's your long-term sustainability plan? And like, I know for a fact what Dave and I wrote was incredibly idealistic about how we were going to continue to support it, but in reality, then we ran out of money and we didn't have time. So yeah, like long-term, because really, you're right, grants aren't sustainable either, at all.
I missed the part before because I'm kind of like exhausted already. But before there was like connecting a FireWire to an adapter to a Mac.
I'm so sorry. I didn't mean to make this about TV Rescue, but
I was like, I don't know if I may say something that has been said before, but if I like the setup we have at the Mediatek that we do on Linux, basically you have a USB stick that you can boot a live distro, and you can put it on
The universe
hardware
has
that
spoken.
actually is laying around that's 15 years old, and I basically, with resources, time, energy, and whatever, I think I can contribute by like this works on Linux with things out of the box with a 30 euro network FireWire card.
Awesome.
Or am I missing something?
No, I mean, the project's been on for a while, and the document's been there.
yeah, and Jerome and Dave can correct me if I'm wrong. I think there's been some progress with the Linux end of things, but it's still not working on Windows necessarily. But the idea behind that project is that it will eventually.
My point is getting all, what you just said and just putting more money into closed systems that definitely like work against all of us.
This is an open source tool that
Mac isn't. Just my point was like at the end of that thing, the Mac isn't. So
Sure. Yeah. No, I would love to be out.
I
from
know
under.
Brianna's issues with like a DV ingest. Like it doesn't work on a Mac anymore. It doesn't work on a Mac anymore. I'm like, you have a PC. I have the solution. It works for 15 years. Could you please? I know. And I have
Not
so
necessarily supposed
much
be about
to
DV
do.
rescue. But thank you.
As I developed that, so I can speak a bit about it. There is a version for Linux too, but the issue is that for connecting the DV, the cam recorder, it is only FireWire most of the time, and finding a FireWire card for a PC and not a Mac, and it is also difficult. So it does not exist anymore. So where do you find a FireWire card? It is difficult to buy one. Sorry?
Alex, get the Warhammer out.
Yeah.
If you haven't played, great
But,
game.
yeah,
We'll
just-
get figurines later.
Thank you.
Thank you.
Okay. Thank you, everybody. Thank you, Libby, and thank you, all of you, for contributing to this last community conversation. Thank you, Lorena. Yeah, thank you all for a great first day. Thank you. So a couple of announcements and a couple of thank yous. Thank yous to all the volunteers today. Thank you to all the live stream for attending online. Thank you so much, and hi and bye. I don't know if everybody wants to wave again. A couple of announcements. A couple of announcements. Here we go. So we have the playlist is here. You can access the playlist that we had last night. Thank you, Joey. Okay, so once we break, the speakers of this afternoon come to the front, please, for a photo. I believe the photographer is around. That would be lovely.
The speakers for tomorrow too, because the photographer won't be.
Oh yeah, so we're also going to anticipate. Yeah, so everybody who's presenting, please just stay in the room, and who has presented. Then there's going to be a group photo again in the main foyer over there. And then at 5, we have the tour of the reading room library, which is open to everybody. And in between there's still some food where we all had food and drinks. So if you're hungry, if you want a snack, go ahead and feel free to have some in the reading room.
No, in the Richard Hayes.
Richard Hayes, sorry. I'm getting confused. So is this where I plug in the DV end or the other end, and then I press play? Is it incompatible on Linux or? Sorry, y'all. Okay, thank you so much. And then finally, yeah, so dinner's on your own. However, do look at the everything you ever wanted to know about Dublin but were too afraid to ask sheet that the National Library has put together. There's a lot of recommendations on there. If you have really good suggestions, put it in the group chat. And then finally, I don't know if anybody of those guys are here, but if the reading group of Ulysses could provide a book report for tomorrow, that would be lovely. Couple of slides with a thesis. I think we'd really appreciate it, and if you could bring some camembert sandwiches and red wine for us. Thank you so much. Okay, and so yeah, so tomorrow we're starting at 9 a.m. There's no social dinner tonight, so there's no excuse for you to being late due to scheduling social events. Okay, this is last slide. Okay, so thank you so much to everybody. Thank you to the NLI staff. Thank you to all of you. And yeah, I'll see you tomorrow. And on live stream, I see you tomorrow too. Have a good night, have a good evening. And please, those who've presented are going to present, stay here. All the others can already mosey over to the main foyer and find Kieran in the Lego ensemble. Thank you so much.